For almost a third of Earth's history, the air held almost no oxygen. A single breath would end you. And yet, under an amber light, the ocean stayed liquid, continents learned to float, and life may have practiced in whispers. Why care now? Because this breathless world set the thermostats we still live by, greenhouse balances, tides from a nearer moon, the quiet chemistry that might have started us. Tonight we'll read old clues, ancient zircons, greenstone belts, iron-striped stone, perhaps stromatolite textures, softly, but their stakes reach us still. Climate, habitability, our place in deep time. Stay with me. We'll ask how a dimmer sun kept the seas warm, where the plates already drifted or the crust simply breathed in place. What rivers without roots felt like, where life could have hidden, vents, tidal skins, warm dark pores, and how tiny oxygen oases might have been the first hint of tomorrow. Imagine an Earth so young that the word familiar does not yet apply. Not to the air, not to the sea, not to the colour of morning. We drift back quietly, beyond mountains we know, beyond forests and coral and the first whisper of bone. We pass through the haze of memory into a time that is more sensation than seen, a time called the Archean. It begins, perhaps, around 4 billion years ago, when the worst of the hammering from space has eased, when the planet's fever, so hot it once glowed, has come down just enough to condense its breath into rain. What follows is not a single picture, but a mood, a long inhalation before the world learns to sing in oxygen. The light is different here. The sun, younger and a little more distant in its heat, gives off less fire than it will later, not darkness, but a gentler flame, and between that light and the ground lies an atmosphere not yet tuned for blue. It is thick with water vapour, with carbon dioxide, with nitrogen that will one day be the air you draw without thinking. There may be methane made by rocks and later by microbes, and a fine organic haze that tints the sky. Under such a veil, Rayleigh scattering, the reason your sky is blue today, competes with particles that prefer to warm and soften the palate. So the morning might open not in cobalt, but in copper, not a crisp cerulean, but a muted, tea-stained amber, a dawn without blue, and then rain. Not a passing shower, not a brief summer mood, but ages of condensation, countless cycles of cloud and fall, hiss and steam, crossing a planet still furrowed with heat. The first oceans do not arrive in a single moment. They gather, they listen to gravity, they find the lows and fill them, over and over, until basins become seas. The coastline, if we could call it that, is raw and dark, volcanic, young, still in conversation with fire. Black glass and green volcanic minerals shine when the clouds lift. Where the lava is newest, the shore smokes. Where it has cooled, waves polish its edges like slow hands. Stand for a moment on such a shore, or rather, imagine standing. There are no trees to cast shade, no grasses to hold the sand. The only shelter comes from rock, from ledges carved by water and time. The wind has a mineral scent, like wet stone warmed by breath. When rain eases, the air might feel thick, a little heavy on the skin, as if the planet still exhaled steam from deep within. The soundscape is restrained, water falling, water boiling where it meets hot rock, and in the distance the low thunder of a caldera remaking the horizon. Above, the sun is a pale disk behind gauze. Sometimes the haze thins. You glimpse a harder glare, a brighter coin of light, a suggestion of the sky to come. But often it is softened, the edges rounded, the colours diffused. Even the shadows have a gentler bite. Nights, too, may feel different, crystal clear after storms have wrung the air dry, or milked out by lingering vapours. Stars would still be there, old companions, but the familiar constellations mean nothing in a heaven where there is no human eye to stitch them together. Out at sea, the surface forms without the help or the drag of floating life. No mats of plants, no darts of fish. Waves move like an unburdened thought. Whitecaps, if there are any, flash against dark water that is young in its chemistry. Perhaps the seas are briny, but the recipe is still changing. Salts dissolving from fresh volcanic crust, ions teaching each other how to dance in an infant ocean. Suspended in that water are metals, silicates, the whispers of iron and silica that will one day settle into bands and stories. The ocean's color is deep, partly from depth, partly from the particles that swim in it, partly from the sky it reflects those ambers and greys and occasional startled blues when the haze clears. The continents, as we think of them, are not quite themselves yet. Instead, there are beginnings, thickening rafts of lighter rock, crotonic seeds, patches of buoyant crust that refuse to sink back into the mantle's slow convective pull. Some rise as islands, stubborn, low-lying, rimmed with black beaches. Others lurk just below the surface, shallow banks that change the tone of the water from iron to jade. On these early lands, the landscape has a bare honesty. No roots hold the soil because there is so little soil to hold. The first powders form where water chews at rock, where thermal shock fractures glass to sand, where chemical weathering, still learning its steps, taps minerals and finds what will dissolve. Walk inland, gently, minding the heat, and you might find a plain of basalt cooled into columns, a field of pillow lavas that froze underwater, a slope of ash soft as flour. You might come upon a hot spring, mineral-rich, rimmed with colors that hint at chemistry, at lifeways not yet confirmed. Steam curls from it, the vapor faintly sharp, metallic on the tongue. Around it, the ground is coated with thin, delicate films where minerals precipitate as water cools. These are the planet's first handwritings lines, and layers that remember temperature and time. And yet, for all this heat and rock, there is a quiet settling. The Archean is not a single explosion of violence. It is a long conversation between cooling and keeping warm, between a faint young sun and a sky that learns how to hold heat close. Clouds play a gentle game of return, catching warmth that would otherwise be lost to space. Carbon dioxide does its work, perhaps joined by methane, both nudging the needle toward liquid. It is a careful balance, and perhaps it wobbles, sometimes too hot near the vents, sometimes too cold in the shadow of a long wintering cloud. But overall, the oceans remain present, persistent, an enormous mirror that gives the sky a voice. We have not yet talked about life, and that is on purpose. In this first chapter, the world is a room being prepared. The curtains are drawn, the air is warmed, the floor is laid, the windows polished by rain. If life is present, and there are hints that it might be, even this early, it is not yet the author of the atmosphere. There is no oxygen for it to leave in the sky's ledger. There is no ozone to shade the surface from the sun's harsher thoughts. The light that falls on rock and sea carries more ultraviolet bite. Perhaps that is why the low places, the shaded pools, the clefts in rock and the undersides of thin ice will later matter so much. For now, the beauty is in basics. Thermal gradients, hot to cold, become engines. Minerals act as quiet catalysts. The architecture of the crust changes tone from basalt to ultramafic, to the beginnings of granites, as water and heat and time make their deals. Deep beneath, mantle plumes may rise like slow-motion torches, forming volcanic plateaus that lift and cool. Above, raindrops learn the taste of the land, dissolve what they can, return their stories to the sea. If you listen closely, you might hear tides stronger, perhaps, than those of our time, because the moon was nearer then. The pull and release would be more pronounced, the edge of the ocean advancing and retreating with firmer steps. In the shallows, that movement lays down rhythmic layers, wet, dry, fine laminations that will become a kind of clock in stone. Under amber skies, shorelines breathe in this tidal meter, making and unmaking small worlds, leaving behind cracked mud like delicate maps. Weather comes in long syllables. There are no trees to break the wind, so gusts may rake the plain with a free hand. Dust lifts from fresh ash and settles in thin veils on the next ridge. Lighting finds easy paths in a sky rich with vapor. Thunder walks miles. When a storm breaks over the ocean, the sound is oceanic, not just in pitch but in meaning. A planet-sized drum, water on water, a harmony of impacts that smooth thought and slows the heart. And then there are the silences. Between eruptions, between showers, between the moon-pulled breaths of the tide. The planet is not busy in the ways we recognize. There are no insects to sing at dusk, no leaves to sigh under rain. The quiet, where it exists, is deep, broken only by the hiss of cooling rock, the small chime of pebbles in a backwash, the ticking drip of water from a lava shelf into a pool below. Here, in these pauses, the mind rests. The imagination begins to see how a world could cradle chemistry for a very long time. Colors, too, have their own language. The land is black and greenish, where olivine shows, red where iron oxidizes in local pockets, cream and white where silica blooms around a vent. The sea is iron dark in deep water, bottle green over shoals, tea brown where rivers thin and tentative enter with their loads of fresh-cut minerals. The sky rotates through slate and apricot, tarnished brass and pearl. On rare, clearer days, the blue comes through. Not bright, not yet the dome of later eons, but enough to hint at possibilities. If we could hold a handful of this world's air, we might feel it heavy with breath that is not ours. Carbon dioxide presses, water vapor steams. Nitrogen is there, the quiet partner. Methane, if present, adds a sweet, faintly sharp tang. There is no oxygen to speak of. Maybe small pockets, transient oases made by light and rock, and perhaps by early metabolisms, but not the free and generous oxygen that will one day paint rust in deserts and fuel quick beasts. That absence changes the chemistry of everything. It keeps iron in the sea dissolved, lets the sky's color be decided by haze, slows the kind of burning that will later be commonplace. The ground underfoot tells time differently. Instead of forests and bones, it keeps records in layers of volcanic ash, in pillows and dikes, in greenstone belts that are the stitched scars of ancient crust. Walk along a riverbed, thin, braided, unconcerned with roots, and you'll see rounded stones made by water's patience. Some are glassy from fast-cooling lava, others matte, soft-edged basalt. Each one remembers a journey, from vent to slope, from slope to stream, from stream to sea. They stack in beds, according to the strength of the flow, heavy pieces falling first when energy fades, lighter dust drifting far into quiet water where it settles like sleep. Far offshore, hydrothermal vents dot the seafloor like small stars, inverted, black smokers and warm seeps, places where the planet's heat sighs into the ocean. Their plumes rise rich in metals and energy gradient. If life will find a foothold here, it will do so quietly in the dark, long before the sky learns to hold its breath in oxygen. But that is for another chapter. For now, it is enough to know that the Earth of the Archean is a world with places, interiors, and edges where interesting things can happen for a very long time. We close this first look the way we opened it, with light. Imagine the sun sliding behind a stack of pale clouds, its edges soft, its disk of peach fading into grey. The ocean reflects a bruised silver. The islands, dark and blunt, make silhouettes like old teeth. Night approaches not with the chorus of modern living things, but with the soft percussion of water and heat. A star appears, then another, then a web of them, each as they are now, but seen through a younger sky. The air cools enough for dew to form on fresh rock, enough to make steam curl more visibly from vents. The world sighs. It is not empty. It is preparing. Perhaps that is the best way to feel the Archean. At first touch, a long preparation under amber light. A dawn without blue, not because blue is impossible, but because the world is still blending its inks, still working out the ratio of haze to clarity, of warmth to release. In that soft, patient mixing, seas gather, continents begin their stubborn rise, and the stage is set for the faint young sun to meet a planet eager to hold heat and company. We will, in time, ask how such a dimmer star allowed so much water to remain liquid. We will consider the balances and the feedbacks, the greenhouse and the cloud. But tonight, let the picture be simple. Air, water, rock, and light. A planet breathing in and beginning to remember how to live. The sun we inherit in the Archean is not yet the confident star of later ages. It burns. Of course it burns, but with a shyer brightness, a gentler reach. By the slow physics of stellar youth, our star offered less light to the early Earth, perhaps a quarter less than today. On paper that should have meant oceans sealed under ice, a world hushed in white. And yet, the seas in our last chapter were liquid, breathing, tide-drawn, storm-stirred. This is the old puzzle with the calmest name, the faint young sun paradox. The question that asks, softly, how a planet with less sunlight found warmth enough to cradle water, weather, and the slow conversations of chemistry. The answer is likely not a single lever, but a tapestry of small helps, blankets, layered, mirrors tilted, rhythms that adjust when the light shifts. Let us walk through them, one by one, unhurried, and see how a dimmer star and a young, attentive sky might have met in the middle. First, the simplest comforter, carbon dioxide. Volcanoes, so busy in the Archean, exhaled this gas as though it were breath itself. With little land to weather and fewer routes to pry open minerals, the planet's ability to tuck CO2 away in stone may have been gentler, slower. The ocean took what it could, making carbonic acid, nibbling at basalts, growing the earliest carbonates in warm shallows. But the balance perhaps leaned toward a thicker sky of greenhouse warmth. CO2 is not dramatic. It is a patient blanket, catching infrared light, the Earth's own glow, and sending some back down, a quiet return that keeps nights from falling too far. Water vapor, too, joined the work. It is the most immediate greenhouse partner, responsive close to the skin of weather. When the surface warms, more water enters the air. When the surface cools, the air sets it down again. This feedback, this echo of warmth, likely mattered even more on a world with vast open oceans and few high plateaus to interrupt wind and cloud. Then methane, a second quilt, lighter, but with a surprising talent for trapping heat. Before oxygen, methane lingers longer. It can be made by rocks. When hot water meets ultramafic minerals deep in the crust, hydrogen and carbon find their way to CH4. Later, tiny archaeal microbes may have had a say, exhaling methane as a waste of life's earliest meals. In a sky with enough methane relative to carbon dioxide, sunlight paints new chemistry, organic hazes that float like fine smoke. These hazes are ambiguous guardians. They can shade the surface, dimming the sun in a way that cools, but they also protect delicate molecules from ultraviolet harshness, letting other, kinder reactions run. The sky in such moments might have worn a veil, a faint, orange-brown, softening the day. Nitrogen, quiet and abundant, seems less involved, yet it may have been the stagehand that made every other actor louder. If the total air pressure was higher, then a possibility some lines of ancient bubbles and raindrop imprints have suggested. Molecules pressing closer together would have broadened absorption lines, making greenhouse gases a touch more effective at their task. Nitrogen also shakes hands with other gases in subtle ways. When paired with a little hydrogen, the duo can absorb the planet's warmth through collisions, trapping heat that CO2 alone might miss. Hydrogen itself may have been slightly more plentiful in the early outgassing mix, a whisper of warmth slowly bleeding to space over time, but useful while it stayed. Clouds, the soft mirrors and quilts of the lower sky, likely shifted their habits too. Clouds do two opposite things at once. They reflect sunlight back to space, cooling the surface, and they catch infrared light trying to leave, warming it. The balance depends on height, thickness, and droplet size. In a world before forests, flowers, and plankton were strewing the air with tiny particles that seed bright clouds, the droplets might have grown larger, the clouds fewer or less reflective over vast oceans. A little less mirror, a little more window. If that is true, even partly, the planet would have absorbed more solar energy than our present-day cloud deck allows. High, thin clouds, meanwhile, may have acted more as blankets than parasols, encouraging the greenhouse side of their personality. Albedo, the planet's shininess, likely kept to the darker side. Less exposed land means fewer bright deserts and ice fields to bounce light back. Black volcanic rock, wet with rain, is a poor mirror. Deep water is poorer still, without the bright cap of continent-scale ice sheets. The young Earth might simply have drunk more of the sun it received, making the most of a smaller allowance. Under the surface, the planet glowed a little warmer from within, heat left over from formation, mixed with the more vigorous decay of radioactive elements that were then younger and more energetic, meant a higher geothermal flux. This interior warmth did not turn the oceans to steam. It was not that bold, but it added gently to the tally, especially where heat met water directly, along mid-ocean ridges, in basins of hydrothermal flow beneath thin crust where magma lay close. In a calculation where every watt counts, this inward candle mattered. And then there is the thermostat that takes centuries to answer, but answers still, the long carbon cycle. When CO2 in the air dissolves into rain, it forms a weak acid that nibbles at rocks. The ions liberated by this weathering flow to the sea and help build carbonates, limestones, related stones that sequester carbon for ages. Volcanoes return CO2 to the air, like a slow bellows on a cooler planet. Weathering weakens, allowing CO2 to accumulate. On a warmer one, weathering strengthens, drawing it down. In the Archean, with smaller continents and the seafloor doing more of the reacting, the thermostat had a different shape, but it was there, feeling its way toward balance. Basalt at the bottom of the sea is a feasting ground for carbonic acid. Water that seeps into fresh crust alters minerals, locking carbon in, faster seafloor creation, and hotter hydrothermal systems might have been a major part of the drawdown, their rhythms guided by mantle heat and the slow pulse of tectonics, whatever the exact style of those motions may have been in that era. Wind and rotation played their quieter roles. A shorter day, perhaps only 20 hours long, spun the atmosphere faster. The great belts of wind may have curled more tightly. The storm tracks hugged differently to the equator. The updrafts and subsidence zones rhythmically altered. This could have changed where low clouds gathered, where rains fell, and how often the sky chose blanket over mirror. We cannot be certain, but even small changes in cloud geography echo through a planet's budget of warmth. Magnetism enters the story as a guardian more than a heater. A magnetic field, if already present, would have helped hold the tenderest gases against the sun's more eager winds. Hydrogen escapes. It is too light, too energetic at the top of the atmosphere to stay bound forever. But with a magnetic shield, the rate of loss might have been tempered, buying time for that subtle anti-HO warmth to play its part, and for methane to linger before sunlight unstitched it. All of these pieces are possibilities, rather than certainties. The picture they suggest is not one of an overheated Archean, but of an Earth that stayed close to the liquid line, sometimes a little above, sometimes flirting with ice in colder reaches, then easing back toward open water. There are whispers in stone of early glaciations here and there, patches of cold written into the crust like sudden breaths. But the dominant mood over millions upon millions of years appears to be water moving, not locked away. Imagine the arithmetic of a day. Light descends through a sky mild with haze, not blinding but steady. The ocean, dark and absorbent, swallows that light, turns it to a richness of gentle heat. Clouds bloom along convergent zones. Not too bright, their drops a little larger for want of fine dust. Afternoon turns the lower atmosphere humid. Night returns a fair portion of the day's spent warmth back down, with greenhouse gases acting as conduits for memory. Over months and seasons, if seasons were strong with so much ocean to smooth them, the dance repeats. No single step is dramatic, but together they keep rain liquid and shorelines washed, hydrothermal systems busy and rivers, however, rootless, carving, drift for a moment into the chemistry of the sea. CO2 dissolves, keeping the water a touch more acidic than today. That acidity works on fresh basalt, liberating calcium and magnesium that will eventually help make carbonates. A portion of those carbonates may precipitate, not in sunlit reefs, which did not yet exist, but in calmer basins and around vents where temperature and alkalinity flit across thresholds. The rest rides currents until it finds a quiet floor. The act of locking carbon into mineral form, grain by grain, is immensely slow, but time in the Archean is generous. Not all feedbacks run in favor of warmth. If methane in the air grows too bold compared with CO2, the hazes thicken, and the sky becomes more mirror than window. An anti-greenhouse that cools the ground despite greenhouse gases trying to warm it. If volcanic outbursts shroud the globe with reflective ash for long months, sunlight falters. If fresh, bright lava flows cool and crust over into high albedo surfaces for a time, local climates blink toward cold. But each of these is a verse, not the chorus. The recurring refrain remains, a sky that learns to keep a dimmer star's gift near the surface. Touch again the idea of pressure, the weight of air on skin. If the Archean atmosphere pressed a little more heavily, Sound may have carried differently. Wind may have moved with a hushed insistence. Raindrops, forming in air of different density and seeded by a different suite of particles, may have struck with a subtly altered rhythm. These changes seem small, and yet, when sunlight threads that heavier air, it is bent and caught in ways that lean toward warmth. Long-wave radiation leaving the surface bumps into more neighbors on its path upward, lingers longer, visits more molecules. The warmth it represents has more chances to be turned back, held close, shared with the sea. We can read hints of these balances in stones that survived. Banded iron formations, laid down in the Archean Sea, imply iron-rich waters under an anoxic sky. Chemistry consistent with warmth without oxygen. Carbonate rocks from those times tell us that CO2 moved through the ocean. Rock conversation with some confidence. Sediments that formed in fair weather speak of waves and tides rather than ice. None of this is a proof in the mathematical sense, but each is a touch on the same side of the scale. There is comfort, too, in remembering that planets love balance. When the sun gives less, the Earth, through 1,000 small negotiations, takes on a posture that saves more. When the sun will give more, as it slowly does through stellar aging, the Earth finds ways over long arcs to reflect a bit extra, to draw down a bit more carbon, to lengthen the chain of clouds between light and ground. These are not perfect corrections, but they are gentle, stubborn ones. So, the faint young sun, not a threat perhaps, but an invitation for the atmosphere to be more involved, for the ocean to be a better partner, for rock and rain to speak more often. In the Archean, that invitation may have been answered by warmer blankets of greenhouse gases, darker seas that welcomed light, quieter clouds that trapped heat more than they turned it away, and an interior fire that, while modest at the scale of continents, added its own glow. The planet, in this reading, did not defy physics. It used them delicately, persistently. If we could sit at dusk on a headland of black stone and feel the day exhale, the warmth would not be tropical without cause. It would feel adequate, perhaps, kind enough for liquid, kind enough for weather. Your hand on the rock would pick up the memory of sunlight and the gentle retention of a sky that cares to hold what the day provided. Above, clouds thin toward evening, showing a few clearer windows to a darker, more amber blue. The moon, closer then, lifts the water as if it were breathing in its sleep. In the next chapter we will step from sky to sea, more fully, into the chemistry of a young ocean, and the sound of rain that slowly writes minerals into patience. For now, it may be enough to let the paradox soften into a portrait, a dimmer star, a less reflective earth, a thicker, kinder air, and the long, slow cycles that kept these companions in conversation until warmth felt, once again, like home. The ocean, in the Archean, does not arrive all at once. It gathers, like a memory being recalled in pieces, rain upon rain upon rain, steam turning to cloud, cloud to drops, drops to sheets and rivers, rivers to basins that deepen with patience. Where did the water come from? Perhaps from within, locked in newborn minerals, and slowly breathed out by a warm, talkative mantle. Perhaps from without, delivered in fits by wetter planetesimals, and a sprinkling of icy things from the dark. Most likely, a mixture. A planet that both kept what it had and accepted what it was given, then distilled it, endlessly, through sky and stone, until seas were the sensible outcome. Not a miracle, just time and gravity and cooling, writing the same sentence many ways. Listen to the early rain, without forests to comb it into a mist, without tall mountains to snag and wring. The drops may have fallen larger, cleaner, a little faster. The air, dense with water vapor and breath from volcanoes, invited generous downpours. The ground, black and glassy, hissed when the first sheet struck hot rock. Steam rose in white veils that drifted seaward. Each storm left its gloss, its shallow pools in still warm lava, its temporary rills racing to the low places, and then more rain. Another curtain drawn across an infant horizon. Beneath these returns, the ocean learned its chemistry. Not the exact recipe we know, not yet, but a broth with familiar intentions. Sodium and potassium escaped from feldspars as water tugged at young basalts. Chloride, perhaps issued from a sky flavored with volcanic acids, found partners easily. Calcium and magnesium were coaxed from rock, then traded back and forth with the seafloor as temperature and flow dictated. Silica, so ready to dissolve in hot, alkaline waters, ran rich along ridges and vents, then when conditions changed fell out in quiet layers of chert iron, under an anoxic sky, preferred to stay dissolved as a soft greenish ferrous note, lending deep water a tone that might, in some lights, have seemed bottle green or even tea dark, with a hint of metal. Salinity. The ocean's saltiness grew as a slow accumulation rather than a sudden decision. Some lines of evidence suggest the Archean Sea may have been a touch less salty than ours. Others hint it was already close. The truth might be a moving shoreline, locally fresher, near vigorous rainfall and river mouths, locally brinier, where sun and wind beat on enclosed basins. What seems likely is the direction of travel. Rain wearing rock, rock yielding ions, ions adopting the sea as home. Each storm, each rivulet, carried a little more taste downhill, until ocean meant not only water but also the mineral memory of a young planet. Imagine wading. There is no grassy margin, no mangrove tangle, no shells crunching underfoot. Just black glass pebbles, greenish grains, drifts of ash turned to fine sand. The water is warm, perhaps warmer than today, though estimates vary. Your skin registers a softness in the surface tension, a clean feel unperfumed by the later world's marine scents. No seaweed means no iodine tang. Little sulfate means fewer of the sharp, match-head notes that modern waves carry. Instead, there is a suggestion of stone, of metal, a taste at the back of the tongue that hints at iron and silica, at the long conversation between vent and current. Currents themselves may have moved with a wider freedom, with few large continents to block or steer them. Wind-driven gyres could circle more completely around belts of latitude. An equatorial current, broad, deliberate, might have wrapped the planet, redistributing heat in a low, tireless hum. The deeper conveyor, if it existed in a form like ours, would have been tempered by different densities and chemistries, warmer basal heat, altered salinity patterns, a sky modest in oxygen. The result, a circulating warmth that smoothed extremes, a sea less segmented by land, its moods organized by wind and rotation, more than by intricate coastlines. Tides were bolder. The moon, nearer then, lifted the world's water with a firmer hand. On open coasts the rise and fall may have been striking, shorelines advancing and retreating as if the planet were breathing visibly. In narrow inlets, cut into new rock, the flow would quicken to a roar at mid-tide, then relax back to murmurs at slack water. Across shallow shelves fringing small islands, ripples laid down laminae, bright, dark, bright, each layer a pulse, a metronome in mud. Internal tides, great slow waves gliding along density boundaries deep below, may have stirred nutrient-poor waters, bringing to the surface what chemistry could use, even before life took full advantage of such gifts. Far from coasts, the surface was a study in clean hydraulics. No plankton to thicken the first few meters, no floating forests of sargassum, no foam born of proteins. Wind wrote its language directly upon the skin of the sea, cat's paw ripples, long-set swells, whitecaps flaring and vanishing like brief thoughts. Sunlight entered unmediated, a shallower scatter without the pigments and particles of a biologically busy ocean. The colors that returned to the eye were set by water itself, and the metals and silicas it carried, greens and greys, a dim pewter under cloud, a dark sapphire on rare clear days. Below the floor was young and active. Mid-ocean ridges stitched the basins in long glowing seams. There, seawater entered fractures, heated, and returned as altered fluid. Magnesium traded away to the crust, calcium handed back, silica brought up in abundance, sometimes with a bouquet of metals in solution. Black smokers marked the most dramatic of these exits, a soot of tiny mineral grains puffing into cold water and falling as delicate snow around chimney stacks. Warmer seeps were quieter, their gifts invisible but constant. Each circuit was a form of breathing, the ocean inhaling into hot stone, exhaling into colder depths, learning with each pass how to be seawater. The seafloor's youth, meant its average elevation sat higher than it would later, when the Earth's interior cooled more deeply. Hot, buoyant crust stands taller as it ages and chills. It sinks. In the Archean, with ridges perhaps more vigorous and plates, whatever their exact style, turning over faster, a larger fraction of the ocean floor could have been in that younger, higher state. The practical effect: less room for water in the basins, more flooding of any shy land that dared to rise. Proto-continents, light rafts of silica-rich rock, would have been lapped by wide, shallow seas, their edges blurred into lagoons and bars that shifted with tide and storm. Where such shelves spread under warm, mineral-rich water, thin limestones may have crept outward grain by grain, not always built by life, not at first, but by physics and chemistry testing thresholds. Evaporation worked its familiar spell in enclosed places. Volcanic craters breached by the sea became transient salt pans. Rift basins along young margins trapped brines between uplifted walls. As water left for the sky, it invited crystals to take its place. Carbonates first, then, if chloride and sulfate were bold enough, other salts, evaporites from the Archean, are rare in our surviving record, which might suggest many such basins were small, temporary, later erased by heat and time. But the process, the invitation for water to rid itself of load by leaving, surely played again and again, even in a world without plants, sun, wind, and confinement, cooperate. The ocean's acidity, its pH, likely leaned more toward the low side, compared with today. More tow in the air means more acid in rain and river, more carbonic bite within the sea itself. Hydrothermal systems in returning altered water tug the pH back upward. Basalt reacts with acidity and is satisfied. The net may have been a near neutral to slightly acidic ocean in open water, with pockets of gentle alkalinity near vents and shallow platforms. In those alkaline leisures, certain minerals bloom easily, aragonite, calcite, spelling out layers and textures that hold water's memory in stone. Such small havens can be laboratories, not only for crystals, but for whatever chemical iterations will later concern us when we talk of life. Temperature bends this script. A warmer ocean holds less gas, a cooler one, more. If the Archean Sea ran hot, say in the 40s of degrees Celsius in the tropics, CO2 would have preferred the air more than the water, leaving the sea somewhat undersupplied compared to modern values. If temperatures were closer to ours, the partitioning would tighten toward the familiar. Either way, the ocean acted as a lung for the planet, exchanging breath with the atmosphere, buffering sudden changes with a memory that extends over seasons, years, and longer. Storms traversed these wide waters with little to block them. A low spinning up in the subtropics could gather strength across thousands of kilometers of uninterrupted fetch. The waves, organized into long trains, arrived at volcanic islands like patient, repeated knock. Where lava deltas jutted into the sea, the swell undercut them, sent slabs roaring into green water, then rebuilt the shelf with newer flows. Beaches adjusted hour by hour, coarse here, fine there, bars migrating and vanishing with each moon-tided cycle. After tempests, the clarity returned quickly. No forests meant fewer tannins in runoff. No deep soils meant less silt to hang in the water for weeks. Clean lines, sharp horizons reinforced by a sky that, even hazed, could surprise with distance. The soundscape of the open Archean Ocean was spare but complete. Wind spoke in scales of whisper to howl. Waves answered with a palette of shush and slap, and at the cliffs, deep percussion. Rain stippled and hissed, sometimes for days, lighting stitched cloud to sea with bright, silent thread, then sent thunder across the plain of water in slow caravans. There were no whales to sing, no fish to patter in schools, no gulls to fold air into cry. And yet, where vents brooded there was a constant crackle, where tides entered narrow cuts, a cello-like resonance, where stones rolled and sorted, a glassy clink in the swash. It might, to a modern ear, feel like the world's breath heard directly. No orchestra, only the steady tide section and percussion. Beneath these audible rhythms, invisible exchanges wrote the ocean's longer story. Magnesium left the water and hid in the crust during hydrothermal alteration. Calcium entered, encouraging carbonate formation elsewhere. Silica pulsed, high near sources and lower where it rained out as iron and manganese cruised as dissolved travelers, until they met oxidants locally, perhaps from waterfalls of slight oxygen at surfaces touched by light, or were swept into minerals coaxed by temperature and pH. Sulfur cycled mostly between reduced forms. Sulfate, so prominent in modern seas, was a shyer presence under an anoxic sky. Each element had its roots, its bivouacs, its favoured ferries. If we picture the global ocean from far above beyond clouds, beyond the soft haze, it may appear darker than ours, more graphite than azure. Not because it is hostile, but because it is honest. The water carries what the newborn crust provides. The air, in turn, lets different wavelengths slip or bounce. On clearer days, when the amber veil thins, a deeper blue emerges, but often the colour of the Archean is a mineral colour, the sheen of rain-wet basalt writ large. Sea level, in such a world, is not just a line but a mood. With more buoyant seafloor, the basin's capacity narrows, with little ice to lock water away. The ocean climbs into every low with enthusiasm. Proto-continents drown easily at their edges. Island chains blink in and out as lava builds, cools, and is planned off by waves. The average shoreline is not cliff and terrace, but bar and lagoon, and broad tidal flat, alive with ripples that index both wind and moon. If you wanted to cross such a shelf, you would walk a mosaic, hard ledges of cooled flow, knotted fans of pillow lava, fields of gritty sand that squeak underfoot because the grains are still angular. Pools collect in the lee of black boulders and, warmed by sun, become quiet baths where minerals begin to arrange themselves into an art of layers. In those quiet shallows, lamination happens. Thin films of precipitated carbonate, dustings of silica, perhaps even in places the earliest mineral-bound textures that will later be coaxed into columns and domes by living mats. The important part now is not who builds, but that the building is possible, that a certain saturation is met, that water slows down enough to think in lengths of molecules, that temperatures hold steady through long afternoons. The ocean provides these conditions without fuss. It has space, time, and a sky learning the art of steadiness. Even at night, the sea is busy. Warm layers lose heat to the air, overturn a little, settle. The tide moves mass. The internal waves roll like sleeping whales. Along ridges, vents never pause, their chimneys creak and grow, their plumes drift and fall in slow snow. In crater lakes connected to the sea by porous rock, sailing gradients set up oscillations, heavy sinks, light rises, and between them thin, almost invisible sheets slide past one another like pages turning. All of this is gentle energy, the kind that wears edges smooth, that gives molecules chance meetings, that builds stratigraphy one hushed layer at a time. The ocean, in this chapter of Earth's story, is the great equalizer. It mutes the shocks of day and night, tempers the reach of storms, houses the planet's excess heat and returns it thoughtfully. It is also the great archive, catching particles from air and land, writing down the signature of each event in silt and chemical veneer. Millions of years from the moments we are imagining, geologists will open these books as stone and read. Here a warm interval, here a fall of ash, here the murmur of a ridge grown, suddenly more talkative. For now, we simply float above that writing and let the page turn itself. What is the feeling of such an ocean? Perhaps spaciousness, a sense of the planet's skin being more water than anything else, and that water being in conversation with heat, salt and wind in a way that tends toward calm. Not always. There are tempests and quakes, overflows and sudden coolings, but the baseline is a low hum, the comfort of a body at a steady temperature. We will, soon, lift our eyes again to the air and consider its breathless chemistry. The gases that shape light, the hazes that shade, the lack of oxygen that leaves so much iron dissolved, and the sky free of ozone's protective blue. For the moment, lie back on that warm mineral sea and look upward. The sun presses through a thin amber cloud. The moon tugs lightly at your floating limbs. Nearer, more intimate. The shore, dark, simple, keeps its distance. You are adrift on a planet that is finding its balance not in silence, but in slow, repeating conversations between rain and rock, heat and depth. And the ocean, quietly forming, says yes to each cycle, again and again, until yes is the shape of the world. There is a feeling to the Archean sky that is not our own. It is familiar in pressure against the skin, perhaps heavier, perhaps much the same, but strange in its breath. You lift your face and draw in, and there is no bright oxygen to quicken the blood. The air is a patient mixture of nitrogen, water vapor, carbon dioxide, with hints of other, more reactive characters. Methane, hydrogen, sulfurous notes from a talkative crust. Breathless, in the sense of lacking breath makers, and yet not empty. Just, earlier, without oxygen. There is also no ozone canopy, no blue shield gathering sunlight's harsher strands into a high protective layer. Ultraviolet pours down more directly, not as a spear but as a steady, bright pressure on the skin of the planet. Rocks face it, without flinching. Water drinks much of it at the surface, shaded clefts, caves, the undersides of thin skins of ice, and mineral scum become small shelters where molecules can try out longer dances without being snapped apart. Later, when we wonder where life practiced, we may picture these softenings of light. Look up. The color of the day is a negotiation. Rayleigh scattering still leans toward blue, but fine aerosols, born of volcanism and of sunlight teasing hydrocarbons into filigree, lean the other way. A veil forms, sometimes faint, sometimes generous, suspending tiny particles that favor warm tones. Amber washes the horizon. The sun's disk takes on a peach edge. Near noon on clearer days, the dome can move towards slate blue. At low angles, copper and tea. If methane rides high against carbon dioxide, that veil thickens into a true haze, an organic mist that softens shadows, cools the ground a little by day, and paradoxically protects fragile chemistry from ultraviolet impatience. Pressure. The weight of the whole sky on a hand held out. Clues in stone have been read both ways. Perhaps the Archean atmosphere pressed more heavily than today's. Perhaps it was similar. If it was greater, sound would carry differently. Fuller, less crisp. Thunder would round its edges as it walked the coastline. Raindrops, forming in air with different density and fewer seed particles, might have fallen a little larger, striking basalt with a bass note. If pressure was similar, the differences would hide elsewhere in composition, in how light threads the air, in what vapors linger. What did the air smell like? Not of leaves or resin or ocean brine, more mineral. After a rain, the tang might carry a shy metallic edge, iron hinted at from dust and spray, near fumaroles and new lava. Sulfur peaks in, a match-head sharpness, a soft rotten egg undertone, where hydrogen sulfide slips free. Over the sea the breath is cleaner, almost blank, no iodine from seaweeds, little of the modern ocean's organic bouquet. A nose in the Archean would learn rock and rain, warm stone and cloud, and on some days, a faint sweetness undercut by smoke. The signature of photochemical hazes spun from methane and sunlight. Clouds are present, faithful, but different in texture. Without forests and flowering fields and plankton spraying the air with millions of tiny cloud seeds, droplets may grow around a simpler set of particles: ash, sea salt, clay teased from young soils, volcanic sulfate. Larger droplets mean fewer, grayer clouds, less mirror, more window. High, thin veils of ice may still trail like lace, favoring the greenhouse side of their nature. Low decks bloom over warm water where air rises, rain out quickly, and leave broad blue-grey voids that drink sunlight. Storms tower when conditions favor them. Tropical anvils shouldering into the upper air, lightning walking their undersides with eager feet. Lightning, there may have been much of it. The air is wet and warm near the surface, the ground hot in many places, and with land mostly low, sea breezes meet land breezes over generous shelves. Convection has room to practice. Each flash, besides its theatre, writes chemistry in the air, fixing nitrogen briefly, forming small amounts of nitric compounds that raindrops will carry down to rock and pool. These quiet deliveries matter when other sources of such nutrients are scarce. Thunderheads pass, rinsing black slopes, and leave behind a sky scrubbed of haze for a day or three. The blue shows through a bit more, almost startling. Wind has a cleaner voice, No leafy canopies to shred it into whispers, no tall grasses to comb it into silk. Over open water it sings the low, even hymn of fetch. Over young rock it moans and rattles across roughnesses, lifting ash and setting it down a valley away. With a shorter day, perhaps, global belts of wind curl a touch tighter. The equatorial engine hums. Mid-latitude eddies spin off and die more quickly over the sea. You could watch a front approach for hours with nothing to interrupt its line. A grey geometry of cloud stepping across the horizon. Rain beneath like beaded curtains. At night, the sky enlarges, without ozone's blue glow in twilight, and with aerosols sometimes settling after a day of rain. The stars can be both diffused and shocking, each one familiar in place, but unfamiliar in sharpness. Through the occasional amber veil, the moon, closer, brighter, throws a stronger path across water, pulling tides that breathe deeper along black shores. If the planet's magnetic shield was already stout, auroras dance at high latitudes, not often perhaps, but with a broader brush when the sun throws its moods. Greens and reds ripple in silence, reflected in lagoons where pillow lavas cool to soft forms under the night's eye. In a breathless air, fire behaves differently. Brush cannot burn because brush does not exist. Lava burns what it meets, by forcing it to glow, not by blazing in oxygen. There is no quick orange of wildland flame rushing up a slope of resin and needles. Heat moves mostly as radiation, and through the flow itself, sparks from lightning make glass veins in sand, but no forests leap from them. The rare bright combustion tar-like gases, at a vent, hydrogen catching and flaring, sulfur finding a partner, has the theatre of a candle against the black, rather than a conflagration. The physics of light in this air makes days feel a little longer around the edges. Haze scatters the sun outward, smearing dawn and dusk into extended moods. Sunrises are slow, moving through rust, to honey, to milk glass before anything like blue appears. Sunsets reverse in syrupy increments. The last light lingers on steaming headlands, and on the backs of waves like warm metal. With fewer bright cloud fields to reflect the high noon glare, the middle of the day can be less blinding, less stark, a steady illumination rather than a slap. Shadows are soft, more charcoal than ink, somewhere between sea and sky. Microclimates write their own weather. On basaltic flats that cool quickly at night, fog pools before dawn, a thin skin of grey that the first light thins and lifts. In crater lakes heated from below, steam wreathes the surface even at midday. The air nearby smells of minerals, feels thick, sticks to skin. Up wet cliff faces, spray builds fringe ice from dawn chills in colder times, then softens by afternoon into weeping films where carbonate can paint white fans. Each of these small atmospheres is its own room within the larger house of air. Different acidity, different humidity, different ultraviolet temper, all inviting different chemical stories. Higher up, sunlight unthreads gases with patient fingers. Water splits, and molecule by molecule, the lightest hydrogen climbs toward escape. Methane suffers the same persistent picking apart. The sky heals itself by building new things from those fragments. Hazes, acids, subtle flavors that rain will sample and carry down. Over millions of years, this leak of hydrogen to space quietly tilts the planet's chemistry toward oxidation, a slow preparation for oxygen's later rise. But that is a future whisper. Here in the Archean present, the air remains largely reducing at low altitudes, friendly to metals staying dissolved in the sea, friendly to colors in minerals we rarely meet at the surface today. There is a hush where, in our time, life is noisy. Dusk has no chorus. Dawn has no answering hymn. Insects do not embroider the night with high strings. Birds do not sketch the morning. The only regular music the air holds is made of weather and water. Winds vowel, rain's consonants, thunder's drum, surf's deep, ceaseless bow across the same stones. Occasionally a volcano adds brass, long notes that come as pressure waves you feel in your ribs. The absence around these sounds does not feel empty, it feels precise, as if each note had more room to be itself. Walk a little, and notice how the breathless air treats the body. You tire not because oxygen is scarce in a way that threatens our imagination. Here is not a biological experiment, but because heat clings a little longer in humid spells. Because the sun's ultraviolet asks the skin to remember. In the shade of a basalt arch, relief is immediate. Air pooled there is cooler, drier. The scent is cooled rock and a trace of metal. A breeze threads the arch and becomes a tone low, fluted. You stand and listen and realize that, in the Archean, the simple acts of wind and light compose an entire art on their own. Without oxygen, rust is not yet a universal language. Exposed iron stays dark, unless local processes make small, bright exceptions. Film-like coats of orange, where a spring brings faint oxidants, streaks where spray and light push a surface a degree toward the future. Copper greens are rarer, manganese blacks more common. Basalt keeps its greens and blacks. Fresh glass glints. Over time, weathering paints the land in subtle pastels, chemical skins created by water's patient editing, but the screaming reds of later deserts await a sky with oxygen, enough to lay iron down as ochre in the open. Storm days become theatre. A line of cumulus builds beyond the headland, grey upon grey, anvil tops, smearing into the upper haze. The first gust arrives cool, the second carries the smell of distant rain. Then the curtain, sheets of water stitch the sea to the sky. Lightning forks down and lifts again in the same breath. Sound piles up in the valleys, returns as a rolling catalogue of distances. When it passes, drops ring off the rock for minutes, finding ledges, gathering in bowls, scribing temporary rills across the black. The world brightens in the storm's wake. The haze is washed thinner. Even with a breathless air, the day suddenly feels oxygenated, though nothing in the chemistry has made that leap. It is only clarity, light, moving through fewer motes, shadows edged as if with ink. Between such events, the atmosphere is a patient conveyor. It ferries volcanic exhalations from arcs and plumes to the sea. It lifts sea spray inland, salts a young soil, and teaches it how to crumble. It carries the exhalations of wet, warm rocks, water, carbon dioxide, sulfurous whispers to a higher theatre, where sunlight will ask them to become other things. Each cycle nudges the surface and the sky toward conversation. Each conversation, over very long pages of time, becomes a trend. Less hydrogen, more oxidized reservoirs, gentler hazes, as methane's share comes and goes with the fortunes of geology, and later biology. If we set a shallow bowl out on a shelf of basalt and come back over many days, we might find a ring thin, delicate, where the waterline paused and left a trace, perhaps a film of carbonate, perhaps silica's ghost, perhaps just a fringe of fine dust caught by surface tension, and then cemented by dew. The air, even breathless, leaves its autograph wherever it waits. In caves it paints with dripstone. Once conditions arrange, though that art will mostly belong to later ages when relief and rain patterns are more diverse. In the Archean, the signatures are subtler, often microscopic, easily erased by new lava or by burial and heat. Still, they accumulate. What color is a breeze here? It is the color of rain deciding of a sky that does not quite settle on one persuasion. On some days the dome leans blue-grey and distant, like slate rubbed with chalk. On others, it leans toward a tarnished brass that warms everything it touches. At sunset, the edge of the sun becomes a slice of fruit peach one day, apricot the next, lowering into a sea that takes color like a metal mirror. A thin crescent moon, larger than you expect, rests on the horizon with a weight you can feel, and then slips beneath, drawing the tide with it into the dark. The breathless air is not an antagonist. It is a state, a room in which certain possibilities are easier, and others wait their turn. Minerals that would crumble fast under oxygen's insistence linger on surfaces, and in water. Gases that would be brief in a later sky stroll, more slowly methane, hydrogen, carbon monoxide, tracing arcs through sunlight before becoming something else. Lighting writes nitrogen into a form that rock and sea can read. Haze, when it forms, softens ultraviolet and extends the time molecules have to test arrangements. Perhaps the most important feeling is this: the Archean atmosphere is intimate with the surface. There is less between sunlight and stone, less between volcanic breath and cloud, less between ocean skin and the high places where air becomes space. Feedbacks are short, A burst of outgassing makes weather that afternoon. A long rain rearranges chemistry along a coast by evening. The world is not capricious. It is responsive. It is still learning its own balances. We leave the shore after night has fallen. The wind has gone light, as if tired from the day's convection. The stars are a paper pricked with warm pins. The Milky Way is more a smudge when haze lingers, a river of frost when it clears. You walk by ear. Surf to your right, occasional trickles over rock to your left. The air tastes simple. It gives you nothing to burn in your lungs quickly, nothing to sing with yet, and yet it holds heat, near the ground as if it understood the comfort of sleep, breathless. Yes, but not unfriendly. In the next chapter we will set feet on the harder certainty of stone, on cometites and greenstone belts, on the crust's early moods and the way fire learned to write continents into being. For now, the sky closes like a gentle lid, and the sea answers with a long, even exhale. Put your hand to the ground again, and feel a planet that is not done speaking in heat. In the Archean, stone is less finished, more musical. It warps, flows, recrystallizes, as if every rock keeps listening for the last note of magma and is willing eager, sometimes to join the chorus once more. The crust is thin in places, thicker in others, stitched together not by roots and rivers but by dikes and ridges, by lava paths that shine when rain scrubs them clean. It is a world where fire and water meet often, and learn each other's name. We begin with a rumor of earlier time, delicate grains that survived almost everything, old zircons, tiny crystals that suggest softly that crust and liquid water may have been present even before the Archean truly opened. Their existence does not give us a map, only a hint that the ingredients had begun to mingle. By the Archean proper, the recipe is firmer. Oceans widespread, a sky without oxygen, and a crust dominated by dark, magnesium-rich rocks that cool to greens and blacks. Basalts and their hotter cousins. Hotter, that word belongs here. The mantle, then, the Earth's slow convecting interior, held more radiogenic heat than it does now. The difference is not theatrical. It is patient, but profound. A warmer mantle melts more easily, and in different ways, it sends up magmas that can be so magnesium-rich, so hot, that when they spill onto the seafloor or slosh across low islands, they move like heavy oil instead of stiff syrup. These lavas, called cometites by those who love naming things, are almost stories in themselves. Imagine one, a sheet of liquid rock, nearly incandescent, rushing down a gentle gradient underwater, thin as a river yet deep with heat. Where it cools quickly, crystals grow as needles and plates, arranging themselves like frost patterns inside the solidifying flow. Later, when the rock is split by time, these spinifex textures flash like the memory of speed. Comatite does not dominate every landscape, but the Archean makes more room for it than later ages do. It is a signature of a warmer earth, a note in a song that will fade as the mantle cools. Set those cometites beside more familiar basalts, and you can sketch an average day in the young lithosphere. Dikes rise like frozen lightning, thin, dark blades that once fed surface eruptions. Pillow lava stack where flows met water, each pillow a bulbous, glassy sack that cracked and healed as the next pulse shouldered past. Between episodes of effusion, ash falls and breccias, rocky rubble settle into quiet. In time, these volcanic layers bend and fold, squeezed between masses of lighter rock that are thinking of becoming continents. In the Archean record, many of these stacks survive as greenstone belts, named for the chlorite and actinolite and epidote that paint them in mossy hues after metamorphism. They are volcanic diaries, kept under pressure. Walk along such a belt. Slowly, you would see basaltic pillows cross-cut by later dikes. You would step from dense, dark units into a weathered band of volcanic sand. You would come upon a layer so fine it feels like paper, perhaps a quiet water chert, laid down when silica decided to rest. Here and there, iron makes its own rhythm, thin, repeated alternations of iron-rich and silica-rich laminae, banded iron, a calm oscillation in a sea that kept its iron in solution until something somewhere nudged it towards solid. A few flows are not mafic at all. They are lighter in color, dacitites and rhyolites, evidence that not every magma was made the same way or in the same place. Between and around these belts rise bodies of paler, more buoyant rock. Their names rhyme softly: tonalite, trondhjemite, granodiorite, and together they are often summarized as TTG. Their chemistry whispers of basalt that was altered by water and then melted under pressure, perhaps deep in a thickened hot crust, perhaps in the warm squeeze of something like subduction, perhaps in drips and delaminations where heavy, transformed basalt slid downward and took its water with it. The details are debated, but the mood is clear. Water has entered the crust's private life. Hydrated basalts yield light, melts when heated. Those melts rise, cool into pale plutons, and with time, stitch together rafts that float better than their darker neighbors. Seeds of continents, perhaps, scattered across a sea of greenstone. Look down from a height in your mind, and a pattern appears. Domes and keels. The lighter TTG masses stand as rounded highs. The denser volcanic sedimentary belts sag between them like the fabric of a hammock. Under pressure and heat, the whole complex deforms with a strange gentleness. Domes inflate, belts fold and sink, fluids wander through and rearrange the mineral furniture. It is not the grand architecture of later mountain belts with high snow lines and deep forelands. It is closer to a quilted blanket warmed from below, soft rises, deep pockets, everything in motion at once, but rarely in a straight line for long. Was this plate tectonics as we know it, or something else? Here, the Archean asks us to breathe and accept a few possibilities at once. Some lines of evidence suggest familiar motions, oceanic crust being made at ridges, moving, and then plunging down under other plates, arcs of volcanoes above those plunges, little continents colliding in manners we would recognize. Other lines hint at a different choreography, episodic, plume-driven, with the rigid outer shell not yet fully segmented into large, long-lived plates, but instead broken into smaller, more easily reshaped pieces. There may have been times of activity and times of rest, swells of heat that mobilized wide regions, then pauses. The present rock record preserves both kinds of stories, and we are still learning how to read their handwriting. Feel for a moment the dynamics from below. Where mantle plumes rose, the slow boil turned up by deep heat. They impinged on the base of the lithosphere and sprawled, doming the surface subtly, cracking it, inviting magma to come up along radial dike swarms. Flood basalts could spread from these centers, making broad, low provinces of dark stone that the sea lapped with a patient tongue. Along their edges, basins sagged and filled with volcanic debris and sands ground from newly cooled flows. Elsewhere, where denser, lower crust transformed into eclogite, becoming heavier than the mantle it sat upon, pieces likely peeled away and sank, drawing down the rest like a tablecloth tugged at a corner. Each downward motion brought water and altered rock to depth, priming those TTG melts and renewing the contrast between light and dark, float and sink. The temperature at which all this unfolded is not an abstraction. It has texture. A warmer mantle means the solidus. The crossover between rock holds and rock starts to melt, sat closer to daily reality. It took less extra push to make magma. Water, added from the surface in minerals or from the mantle itself, pushed further, lowering melting thresholds and changing what melted first. The consequence on the ground: more frequent intrusions, swarms of dikes stitching through older units, sill complexes that slipped between layers like pages that refused to lie flat. In cross-section, an Archean crust might look less like a layer cake and more like a millefeuille thin leaves of rock, many flavored, each intruded, metamorphosed, bent and healed over and over. Healing itself, metamorphism, was a constant companion. Pressure and heat taught minerals new ways to arrange their atoms: basalts, plagioclase, and pyroxene, giving way to greenschists, chlorite, and actinolite. Then deeper or hotter, to amphibole-rich assemblages, then in places of greater intensity, to garnet and pyroxene again in new company. Each metamorphic facies is a climate for minerals, a room with particular temperature and pressure, where only certain combinations are comfortable. Archean rocks often show the marks of moving between such rooms repeatedly, like travelers with many entry stamps. Fluids thread these rooms: carbonic, aqueous, sulfur-bearing, etching and depositing. redistributing elements into veins, into delicate halos, around grains, into ore bodies, where a later world will go looking for metals. Volcanoes stood at the surface as chimneys for these deeper conversations. Some were broad shields, their slopes gentle with repeated flows. Others were steeper, staccato, built of ash and cinder, and the glue of interleaved lavas. Underwater, many eruptions were subdued, pillows stacking with a muffled hiss while the plume of heat above fed hydrothermal cells. The sea, heavy and patient, pressed into every crack, was heated, and returned to the water column altered and vigorous. Around vent fields, chimneys rose, matured, toppled. Metal-rich particles settled like black snow. The seafloor, in effect, was both factory and archive, producing new crust and preserving in minerals and stratigraphy the very processes that made it. Islands, when they surfaced, did not wear soil for long. Rain found glass, ash, and black sand. It worked them into silt, yes, but fresh lava was always nearby, ready to cover what the weather had just arranged. Where intervals of peace lasted, thin blankets of sediment accumulated, tuffs reworked by waves, tephras laid down by a distant event, sands shared between shore and shelf. Some of these quiet layers record gentle tides, mud cracks, even ripple marks, textures that seem homey against the backdrop of fire. They remind us that even in a hot world, days and nights, storms and calms, set their own humble clock. Inland, if one can call anything inland when land is often small. Granite-like bodies, slowly cooled at depth. Crystals grew large where the heat left gradually. The resulting rock breaks with a wholesome confidence. Its quartz light, its feldspar creamy, its mafic companions speckled dark. Over time, these plutons congregated, stitched together, cooled enough to be strong in a way their surroundings were not. They resisted bending. They deflected strain. They became the cores around which later continents would feel comfortable thickening. In cross-section, they are the pale domes in that dome and keel mosaic, old hearts that learn to say no to the mantle's tug. Between those hearts, belts of volcanic and sedimentary rocks were not only folded, but also sheared, sliced, and transported. Faults moved with both brittle snap and ductile flow. Blocks rode past one another. Small oceans opened and closed at scales too modest to draw on a globe, yet large enough to matter in the local physics of heat and weight. If there was subduction, it may have been shallow in angle, faster in tempo, less organized into long, continent-spanning trenches. If plates existed, many were smaller, more short-lived, their boundaries as much the footprints of plumes and drips as of coherent global conveyor belts. The word most at home here might be episodic. The crust moved in pulses responding to interior cycles and to the cooling arc that governed all. The chemistry of magmas recorded those responses. Some were dry and hot, carrying the signature of deep, anhydrous melting. Others were wetter, more evolved, flavored by crust they had melted through or by slab-like sources carrying water. Trace elements, rare earths and their friends, kept ledgers of pressure and depth, hinting at where melting began and how much garnet or amphibole stood in the residue. We can read those ledgers now with instruments and equations. In the moment, the planet read them as buoyancy. This melt rises easily. That one stalls. This one coalesces into a pluton. That one erupts in sheets. This one builds a light raft. That one darkens the seafloor. Over millions of years, the ratio of light to dark of TTG-like masses to basalts and komatiites shifted. As the mantle cooled, ultramafic lavas became rarer. As water took more elaborate paths into the crust and back out, felsic magmas grew more common. Seeds of continental material agglomerated, thickened, and perhaps, during quiet spells, learned to grow strong bottoms, deep lithospheric roots depleted in the heavy minerals that would make them sink. Those keels, once established, would help continents float higher and survive later collisions. But that is the next chapter's comfort. Here we are still in the era of first contrasts, of experimenting with ways to be buoyant. Stand again on black stone at evening and read the record with your fingers. A chill runs through a vein of quartz that once was a hot fluid's path. The host basalt is softer under your touch, its grains finer, its surface coated with a subtle sheen of chlorite. You move a few steps and the rock changes underfoot, fine layers dipping gently toward the sea. each a page in a quiet water interval. Then abruptly, a blocky outcrop of pale, coarse crystals, an intrusion that fingered through the stack long after those sediments were laid. Above you, a narrow, jagged wall cuts the skyline straight. An ancient dike, tougher than its surroundings, now a ridge, where the rest has eroded. This is what first crust looks like when it has had time to think. Not a single stone, but a conversation in stones, each interrupting and reframing the others until a story, if not perfectly plotted, is at least legible. There were still the great events, of course. Impacts from space that rang through crust and mantle alike, laying down spheral beds far from the craters. Enormous outpourings of lava that reset the local clock to zero. Periods where belts slid and rose enough to make short, sharp ranges. But between these louder pages, the quieter text accumulates hydrothermal veins, alteration halos, mineral lineations that show the slow creep of rock under stress. Metamorphic isograds crossing a landscape like invisible contour lines for heat. If you listened for a century in one place, if the Archean would allow such patience, you might hear most days as water and wind and the occasional tremor. The lava that makes the biggest news in a decade may be muffled by the sea by the time the next generation of flows arrives. The longer work is internal, the thickening of a pale mass here, the sinking of a denser keel there, the slow selecting of stronger combinations. The planet is trying technique. Some will become the rules of later tectonics. Others will fade as the mantle's temperature drops and the crust finds a more settled stride. There is comfort in how stones and fire, once antagonists in our metaphors, are partners here. Water tempers fire, fire remakes stone, stone channels water, water returns to stone with gifts of chemistry. The earliest crust is not a crust in the sense of a brittle shell. It is more like a living rind, healed and rebroken, flavored by its exchanges with the ocean above and the mantle below. If continent implies stasis, this is the before restless, improvisational, still choosing its instruments. Night falls on the green-black belt, and the pale domes glow faintly in moonlight. Steam threads the air from a distant fissure, a white stitch on a dark cloth. The ground holds warmth. You sit, back to a weathered dike, and feel through the stone a kind of memory heat passing, fluids having moved, crystals aligned by pressure long gone. The first crust, for all its fever, is building toward quiet. The kind of quiet a continent knows when it has a deep root and a high, dry center. We are not there yet, but the pieces are on the table. Kamatiet's heat, Greenstone's diary, TTG's buoyancy, and the hands that move them belong to water, to gravity, to time. In the next chapter, we will stay with those pale masses and watch them find each other, crutons forming, proto-continents testing alliances, the seeds of stability taking hold beneath an amber sky. For now, let the stone under your palm cool a little more. Let the fire rest, embers under basalt. The world is learning how to last. If the Archean crust was a quilt warmed from below, then the first continents were the thicker patches, stitched tighter, layered deeper, and most importantly, harder to unpick. Cratons, the word we use now for those old quiet hearts of continents, they are not simply slabs of rock that refuse to travel. They are arrangements, partnerships between a buoyant upper crust and a special kind of mantle beneath a keel, dry and light, that helps the whole package float high and stay calm while the rest of the planet keeps rearranging itself. In the Archean, these seeds begin to appear, not as the massive continents we know, but as clusters, archipelagos of stability learning how to be themselves. Picture 1, forming. Begin with the pale masses from our last chapter. TTGs rising like domes among darker volcanic belts. They cool and strengthen, fluids complete their work, and wander off. The domes, still warm, meet others, some pushed close by broad, slow flows in the crust, some tugged together by the foundering of dense material at depth, some simply inflated until their shoulders touch. Between them, greenstone belts sag and thicken, then fold and rise, then sag again, a breathing motion, not of lungs but of rock changing density and strength with time. Underneath, the critical partner takes shape, a lithospheric mantle keel, as basaltic crust is altered by water and driven deeper, whether by something like subduction in places, or by drips and slumps where heavy lower crust peels away, melting occurs. The melts leave, light and buoyant, to help build the pale crust above. What remains in the residue below is depleted, robbed of easy-to-melt ingredients, and crucially, dried out. A dry peridotite is stubborn. It flows less readily. It is lighter for its age and composition. Over millions of years, such residues, stitched together and cooled, form a keel, an underraft that resists both melting and recycling. The seed now has a root. At the surface, nothing announces this in a single moment. You do not hear a click when a creton locks into place. What you might notice, if you watched long enough, is a change in the quality of motion. The pale domes rise a little higher and erode into broader, lower slopes. The belts between them carry rivers a little farther before they meet the sea. Volcanism remains, but its character shifts toward the margins, leaving the heart to thicken and metamorphose in quieter rooms. The land, such as it is, we name these quiet hearts today: Capfile and Pilbara, Yilgarn and Superior, North China and Slave, and others whose remnants press through younger covers. In the Archean they were not named. They were many small things finding each other by trial and pressure. Some joined into pairs, supercretons perhaps, temporary alliances like Valbara, or later Kenneland, whispered in the rock record. The details are debated. The feeling is not the Earth experiments with large, stable pieces and finds the recipe has promise. How do such pieces join? One story favors familiar edges, converging flows in the crust, arcs of volcanoes above down-going slabs, belts where the hot, wet underbelly of one region slides beneath another and feeds a line of calcaline magmas. These are the signatures we recognize from later plate tectonics, and parts of the Archean record echo them. Trace elements in ancient lavas that smell of slab fluids, belts stitched with accreted terranaes, metamorphic gradients that look like buried edges of plates. Another story leans vertical, not sideways. In this telling, the crust does not yet run like a conveyor of broad, rigid plates. Instead, it wrinkles and thickens in place. Dense volcanic piles sag into their own weight, sagduction. A word with the softness of a quilt settling, and lighter TTG material rises around them. Dipyric like warm wax, easing upward between colder blocks. The belts sink and become keels. The domes coalesce above. A creton emerges, not by collision across thousands of kilometers, but by internal sorting and flotation. In places, both stories may be true at different times, the choreography shifting with mantle temperature, with water's availability at depth, with the strength of the surface lid, between the roots and the roofs. A middle story, lower crust, tells of heat and pressure settling into a long conversation. Granulites, rocks that speak of high temperatures at moderate depth, appear as deep floors to some cretanes. Their minerals, orthoplecoxene, plagioclase, garnet, smoothed into banded grainesses that look like cream, and coffee pulled into long strokes. Such rocks are not born in cold collisions. They are annealed by persistent warmth. The presence of these deep-seated fabrics suggests that parts of the early continental seeds spent time thick and hot, yet dry enough to keep their strength. This is the language of keels maturing, of lower crust learning to stand without slumping back into the mantle's waiting arms. As keels stabilize, magmas from the mantle that do arrive beneath cretons often look different, more potassic, sometimes flavored by interactions with the thick roots. There are intervals where sanaketoids and other mixed heritage rocks appear, melts that seem to carry both mantle vigor and crustal memory. They inject as sills and plutons, building roofs on older TTGs, adding stiffness. Each arrival is a small negotiation. Will the root accept this addition without losing its floating grace? Usually, yes. The dry keel remains buoyant. The upper crust grows more composite, more difficult to melt again. Sedimentary basins learn to linger along the edges of these growing seeds, where a creton's mass depresses the lithosphere nearby. A long, shallow trough, like a hammock, hung from the creton's stiff frame, collects sand and silt, volcaniclastic layers, chemical precipitates. Without plants, the sand is angular, the mud's quick to wash, yet the bisons persist. They have predictable shapes. They deepen where the weight is greatest, shallow where the keel pinches upward. Turbidity currents underwater, avalanches, scribble their course to fine rhythms in stacked beds. In time, when belts at the margins thicken and press, these basins crumple into new folds that are added quilt-like to the creton's corona. Erosion, still a blunt tool without roots to pry and blankets of soil to move, nonetheless begins to write gentler slopes across the survivors. Rivers, brief and braided, cut across light granitic bodies and rearrange their wastes along tide-flushed shelves. Quartz becomes the steady grain, hard and simple. Feldspar weathers quickly and is reborn as clays that travel farther. In places, chemical sediments banded iron, cherts, early carbonates, carpet broad platforms fringing the pale interiors. Each layer is a quiet vote in favor of stability. You cannot deposit long, even sheets if the ground is tilting anew each decade. Deep below, the keel continues to dry and harden. Magma that tries to pass through it loses its water to minerals. Without that water, the melt stiffens or stalls. The keel's crystal lattice refuses to part. The residue's buoyancy increases as melt is extracted. It is as if the root keeps wringing itself out, becoming a sponge that's already been squeezed, light, resilient, reluctant to take on new burdens. In later ages, such keels will be proven by messengers. Diamonds carried up in fast, volatile rich eruptions from below. Diamonds that need both pressure and time to form in the keel's deep rooms. In the Archean, the rooms exist. The messengers, when they come much later, will tell us so. Step back to the scale of thousands of kilometers and try to see how these seeds arrange themselves. They are islands of stiffness in a softer, warmer world, rafts that, once made, alter the currents around them. Mantle flow diverts, heat insulates beneath, melt paths kink and gather at their margins. Microplates, pieces smaller than later continents, jostle and attach along belts that are in the surviving rock record. Zones of intense deformation, high-strain corridors where rocks have been milled fine and then glued back together in fabrics, aligned like combed wool. A craton's edge is rarely a single line. It is a zone, a several 100-kilometer-wide archive of arrivals and departures. And what of time? Stability is not a switch. It is an accrual. Over tens of millions of years, a seed survives a half-dozen heating episodes that might have undone a week apiece. It gains mass, loses little. Over hundreds of millions, it acts as a faithful platform for sediments, collecting histories without losing its own place. Some seeds merge, some rotate and collide, some part and drift like ice flows in a slow, hot ocean of lithosphere. The names we give supercontinents for the late Archean and early Proterozoic are our way of labeling these experiments at a grander scale. But the texture of each is all in the edges, where greenstones were folded and TTGs were stitched, where bisons deepened and were later lifted dry. The debate over style, horizontal versus vertical, matters for feeling the landscape. If horizontal motions were already king, you could have traced long volcanic arcs with your eye, strings of islands smoking above broad slabs descending at shallow angles. You could have walked belts that felt familiar to a geologist from a younger world, thrust sheets, melange zones, accretionary prisms. If vertical motions dominated, you would have seen more domes and basins repeating, more boudinaged layers, rocks pulled like taffy, more intrusive diapirs, frozen mid-rise, more signs that the crust thickened in place like a pot of slow porridge. The Archean likely hosted both, episodic plate behavior, interleaved with pulses of sag and diapirism, when heat swelled, or when keels were not yet set. The same craton might carry records of each in adjacent blocks, later stitched into a single quiet face. There is a human temptation to ask which chapter was the first true continent, but the Archean refuses single debuts. Some seeds thickened early and endured, others matured later. A few were unmade and recycled, leaving only their influence in the chemistry of younger rocks. A Cretacean is more process than event. Build light crust, drain and dry the residue, couple the two, survive the next warm breath from below, thicken again, cool, then act like a stubborn cork in a pot that keeps boiling. On the ground, what did such a seed feel like underfoot? Perhaps different in its quiet. Volcanic plains still lay nearby, but the heart itself felt older, its rocks coarser and paler, its fractures healed in ways that resisted the next quake's invitation to slip. Springs were fewer but more predictable, following joints in granite rather than erupting wherever lava met the sea. The relief was nuanced. Rounded highs, broad saddles, valleys floored in resistant quartzites, where old sands had been pressed and turned hard. The sky above was the same breathless air we have lived with for chapters now. But the way wind moved over this landscape was new. More echoes, more long whistles in granite clefts, fewer sudden rumbles from fresh collapses of cooling basalt. At dusk, when the tide retreated across a broad shelf trimmed to the craton's edge, you might see rows of ripples, symmetrical, rank on rank, nothing to disturb them but wind and moon. Farther out, a dark line marked a volcanic margin, an island arc perhaps, or the lip of a younger basin. Between, shallow water stood warm and mineral-rich over a pavement of firm rock. In places, thin carbonate skins had begun to spread, fragile, laminar, testaments not only to chemistry, but to time without interruption. In the long view, the appearance of cratons changes the climate of geology itself. They provide anchors for tides, scaffolds for weather patterns, stable shelves where later life will prefer to stand and photosynthesize, lightened blocks that change the load on the mantle, and coax plumes to find edges rather than middles. They also give the carbon cycle new rooms, platforms where carbonates can accumulate over millions of years, then be preserved insulated by the stiffness below. The Earth with cretons is an Earth with memory, and memory, even geologic, is a kind of gentleness. It lets processes layer instead of erase. One more motion quieter than all. Drift, not the continental drift of schoolroom arrows, but the slow translation of a seed relative to heat sources in the mantle. A keel passing over a plume edge warms and softens along one side. Margins there become fertile for magmas. New arcs may light. The opposite edge in the lee of heat cools and thickens, gathers basins that sag deeper. Over time, the shape of the creton's basement changes, not at the scale of mountains, but in the subtle topography beneath, the unseen map that will control where later rifts choose to open, where later rivers will cut, where later ice, when ice finally arrives on this planet, will prefer to sit. We close with a simple touch, palm on a pale demi streaked with darker bands. Those bands are not paint. They are the stretched, transformed ghosts of older rocks pulled into ribbons by pressure, then frozen as the creton cooled. Run your fingers along them and feel the direction of past strain. North-south here, east-west, there, cross-hatching like the grain in old wood. This is what endurance looks like when translated into stone. A record of many small adjustments rather than a single heroic stand. Seeds of continents. They did not arrive with trumpets. They settled in, dried out, and learned to float so well that the rest of the world, no matter how restless, could do little to unseat them. In later ages, their margins will be the stages for drama. Their interiors will be calm tables where quiet sediments accumulate and are saved. In the Archean, they are the promise that not everything must be remade each time the mantle breathes. Some things can last. In the next chapter, the seas will meet these growing edges. We will walk rivers without roots, feel stronger tides along new shelves, and count shorter days on a planet still spinning a bit faster than it will. For tonight, let the creton under you hold. The wind has gone light. The rock is warm, from a day beneath an amber sky, and below, the keel, dry and buoyant, keeps its slow, faithful watch. Walk across a land with no shade, no trees to stitch the wind into whispers, no grass to hold the ground in place, only black and pale rock, ash worked to grit, thin veneers of early clays, and water, arriving in moods. Rivers, as we think of them, are creatures of banks, of roots and reeds, and the patient engineering of plants. In the Archean, banks are a suggestion at best. Channels form, yes, but they do not keep promises. They split and reunite, braid and abandon, because nothing ties their edges shut. After rain, the surface seals quickly drops beta crust into being, and flow escapes downhill as sheets, not threads, until a low line gathers it. There, the channel sharpens, for a day, a season. Then a new storm writes a new path. The day itself is shorter, perhaps 20 hours, perhaps a little more. The planet's spinning with a briskness we do not know. The moon is nearer, its pull is firmer. Tides breathe deeper along these raw coasts, and that breath reaches inland wherever the sea can persuade a valley to admit it. Estuaries, where they exist, are not meek. Twice daily, sometimes with an extra pulse riding a lunar rhythm, water reverses, up channel and back, combing gravel into herringbone patterns, turning bars about face, leaving laminated ledgers where careful mud keeps count of the moon. In places, a bore may surge inland at spring tide, low, glassy wall curling upriver, shouldered by hiss and foam, then settling to a long, deliberated return. Without roots, banks, slough, sand and silt do not knit, they slide. Cohesion is a shy commodity, some from early clays weathered out of basalts, some from dissolved salts precipitating as films in drying mud. But the chords are weak, easily snapped by a rising run of water. Channels go wide and shallow, branches wander across broad bars. The plan view is a map of indecision, 1,000 small threads, glittering in sun, rearranging themselves with each moon-tugged tide and storm. At the head of all this, rain speaks in two accents. There is the slow, day-long sky-wide fall from warm, hazed fronts, and there is the sudden vertical insistence of convection. Both can be generous. With little cover, drops reach the ground big and honest. Their percussion is audible: drums on basalt, soft cymbals on ash. Where they hit hot rock, steam lifts, takes edge off the air, and beads the skin. Rivulets find one another quickly on slopes without sponges. Sheet wash flashes bright, then dark, where it cuts to fresh glass under a thin, weathered rind. In such streets of water, stones learn quickly to round. Basalt breaks into platy fragments and nubbly pebbles. Komati, to little tougher, gives denser clasts that the stream carries only when its pulse is up. Close to the source, angular blocks ride in noisy company, rattling, then settle in fans at the foot of slopes when the flood's breath shortens. Farther out, the music gentles to a hush, sand moving like a thought, bed forms migrating under a low meter of current. Each storm rearranges the orchestra, retunes the bars, smooths the edges. Some valleys are not valleys yet, so much as attitudes of land. A slope remembers a fissure where lava once ran. Water remembers it too, and returns. Another slope is a long apron below a pale dome. Granite, or TTG, warmed and softened by weathering. Feldspar quick to become clay. Quartz resisting and collecting. There, sheet flow pulls long, gentle tongues of sediment downslope toward a tide flat. In a few days of dry, crusts form, polygonal cracking as they shrink in the sun. A mosaic of edges that record each evaporation as if it were a mood. The next rain laces those polygons with darker lines, re-wet, redrawn, keeping a tally the sky will soon erase. On the coast, the interplay is continuous. A tide-delivered flow brushes up the estuary, slackens, turns. River-derived sediment, still coarse without the fine, root-bound silts of later ages, spreads in shoals that migrate under reversing currents. If you stepped out at low tide, boot prints would fill slowly with seeping, iron-dark water. Lines of ripple marks would lie in sets, one oriented landward, one seaward, crossing like the strokes of a practiced hand. In deeper channels, dunes on the bed would face first one way, then the other, their slip faces switching allegiance on the clock of the moon. Where rivers have room to forget the sea, they become mosaics, braided plains bright in sun, set with bars like islands of intention. There, without plant-stiffened banks, islands are temporary prints of last month's highest water. Channels are wide, their margins feathered with miniature deltas where minor threads rejoin the main. The flow's sound is complex, scatter, hiss, a constant tinkling as grains click and settle, the lower tones of logs conspicuously absent. When wind rises across such plains, it lifts dry sand into low veils that skate the ground, saltation bright as a shimmer, then fall when the breeze tires or the grains encounter a wet patch. In the taller places, fault scarps, volcanic rims. Gravity writes its own gullies. Frost is rare in these warm intervals, but thermal shock still works cracks wider. Rockfall litters slopes with talus that rain sort and rearrange, sometimes carrying blocks a surprising distance when short-lived torrents turn gullies to chutes. Without roots to pin the talus, fine material drifts. Fans at the foot of these slopes are coarser than our modern eye expects, their surfaces armoured in big pieces that only the strongest pulses disturb. Soils. If we use that word, we must whisper it. Proto-soils? Perhaps thin mantles, where rain and carbonic acid have had time to soften feldspars into clays, where iron has begun to paint grain rims green or brown in local oxidizing pockets, where silica gels along microfractures. These layers are patchy, easily removed by a single storm, then made again. They lack the deep structure biota will later weave. No burrows, no root casts, but they still matter. They color runoff. They give the first hint of cohesion to channel margins. They introduce a softness underfoot that was not there the weaker lava flow cooled. Chemistry shadows this physical theater. Rain, flavored by CO2 and a little by volcanic sulfur, arrives with a gentle bite. Fresh basalt returns calcium, magnesium, sodium to solution. Streams carry an early tea of ions, clean mineral, with an iron note that deepens in quiet pools. Where water stands and warms, carbonates can precipitate on their own, painting edges with thin, crisp veneers, white against black, especially where the air is briefly less acidic after long rains. Elsewhere, in shaded hollows, silica blooms into delicate skins. Each deposit is patience, a record of hours and days, not of centuries. Because the day is shorter, the rhythm of everything is a fraction faster. Sea breezes turn inland, and then turn back with a little more haste. The afternoon's convection does not carry as far before evening calms it. Tides climb and drop while shadows still seem long. The Coriolis effect, quiet hand on winds and currents, may be a touch stronger for the quick spin. Eddies over sea and land draw tighter spirals. Storm systems, in the absence of large continents, are free to circle broad belts with less interruption. Rivers feel these tempos not as thought but as frequency. Fresh pulses stacking in patterns that differ from ours, bars migrating in steps set by moons and sun that visit each stage in slightly different lighting. What does a flood look like here? It begins with a sky that darkens from amber to slate in an hour. Towering grey steps climbing inland from the sea, edges smudged into the upper haze. The wind swings, cool and metallic in scent. The first rain arrives in coins, loud on rock. Within minutes, every minor depression has a thread in it. Within an hour, the broad face of the slope moves as one, sheets converging, forming threads carving V's deep enough for a person's ankle. Where a channel existed yesterday, today's flow seeks an easier line and finds it where a bar stood dry. It softens, slumps, becomes a shoal. At the tide limit, the river meets an incoming pulse, rises against it, then rides over, a mingling of brown and green that quickly becomes one color, tea, with iron and ash, and a little dissolved glass. When the flood's back is broken, silence after is not silence at all. It is the small talk of water leaving, drips from ledges, the sigh of a still swollen braid slipping into a slower course, the occasional clatter of a pebble giving up its hold and shifting down a shallow face. Sun returns, patient. Steam takes whatever coolness was left under rock and carries it into the breathless sky. The smell is of wet basalt and something faintly sweet, perhaps the photochemical veil relaxing after a long rinse. These rivers without roots build things too. Quietly, they stack bars that once abandoned become small terraces. They lay down couplets of sand and silt where tides reverse. Ledgers a careful reader can count. They fill basins along the young creton's edges with deltas, whose toes are tidally tugged into ruffled fans. In time, some flats keep a surface long enough for thin flat layers to bind, lamina, that read like pages when later cut. In a few places, thin films on those flats trap grains and hold them together, rippled skins that one day will be debated as storm traces, or something living's early handiwork. We leave that for later chapters. For now, the maker is water. Desert? Perhaps in patches, if a region sits leeward of a high, warm dome. If winds arrive dry after long sea paths under inversion. If rain shadows develop even in a world with much ocean. Then yes, dunes can wait. Without plants, they wander unrebuked, their crests migrating with each strong blow, their faces collapsing in low sighs that can be heard a little distance away as a sifting murmur. Most sands are volcanic, dark, heavy, quick to cement when wetted. Their color makes desert light different. Less glare, more charcoal silver at noon, purple at dusk. Such fields, when rain does arrive, accept it greedily and become something else entirely. Glistening aprons, then fans, then a network of bright threads, until the next dry returns. The moon, nearer, keeps time with the confidence we can feel. Its path across the sky seems a little larger. Its pull draws water higher onto shelves, pries bars loose, sculpts stairways of ripple along flats in a single afternoon. On spring tides, estuaries become rooms for rehearsals, the river forced to speak a tide's language. Then hours later, a tide forced to speak the river. Neap tides give the channels rest. Let muds lie without being combed quite so hard. Let delicate structures survive a few cycles more before the next full-throated reversal. If you stand at the edge of a creton's shelf on a day of clear light, you can watch all of this drawn at once. Out where the color deepens, long lines of swell march clean, undisturbed by kelp or drift. Closer in, a field of Barchan-like ripples crawls across waist-deep water, their horns pointing down current. Along the sand flats, tiny dunes stack as crosshatch triangles, morning set pointing landward, afternoon seaward. In a channel, a patch of suspended grains makes the water opaque when a gust crosses. Seconds after, it clears to a green that is almost bottle. The only animals present are, perhaps, microbial and quiet. There are no footprints to stir the record, except your own imagined ones. Night compresses the soundscape. Without leaves to rustle, you hear the physics directly, the low burn of a distant surf, the tick of cooling rock, the thin, endless, silver noise of trickles sorting grains in the dark. The tide turns, somewhere up channel. A bar fails along one edge with a soft clump, and then the water, eager, eats the new cut, makes it clean. Overhead, the moon travels a little faster than you expect, as if impatient to show the second tide before dawn. Stars are a veil between weather days, a sea of pinholes through which the black shows. Geologists of much later ages will find these places in stone. They will cut through a pale slab and see cross beds in opposing sets. Tide's handwriting. They will count thin layers, thicker, thinner, thicker, in stacks of silt, and infer the beat of springs and neaps and the number of days in a month. Then they will follow a channel fill from coarse at base to fine at top, and imagine the flood that made it, the slowing that left silt to cap. They will hold a piece of rippled sandstone and lay a finger into each trough, and know the wind's direction for a week. 5 or 10 lifetimes of continents ago, all of that from rivers with no roots to slow them down or to complicate their gestures. There is, through all this motion, a calm center, gravity in the moon and the patient will of water, to find the low line, even without plants, even with a shorter day and a nearer moon, even with a sky still learning its balances. The work tends to the same ends, moving high to low, rounding sharp to smooth, stacking chaos into order you can pick up and read. The difference is pace and texture, fewer knots in banks, more decision in tides, a quicker turn between flood and hush. We leave the bar at last. Light, the river, in returning toward the sea, bares its ribs, shallow channels separated by higher ground. Your steps leave prints that the next smaller pulse will soften, then the next erase. The smell is mineral and a little sweet, as if distant steam mixed with rain-stained stone. Upstream, a thin vapor rises where the day's last sun caught a wet slab and asked it to speak. You listen. The language is gentle. It says wait, and move, and wait, and move until in the patient arithmetic of many tides and many rains, a land with no roots still learns to hold shape. In the next chapter we will attend to whispers, textures and chemistries that might be the first drafts of life's handwriting. We will keep our hedges close and our senses open. For now, let the tide finish its sentence, and let the night keep what the day arranged. If the land is a ledger of water's handwriting, the flats at the sea's edge are where another author may have tested a pen. We do not see creatures here, no shells, no bones. What we find, when the rocks are kind and the light is right, are textures, rhythms, films, unfolds in thin layers of carbonate or silica that suggest perhaps a living patience once lay there. The word often used for these patient architectures is gentle yet sturdy, stromatolite, laminated, layer upon layer, domes, columns, low mounds, sometimes conical rises, built grain by grain. In our era, such forms can be made by microbial mats trapping sediment, binding it, then growing upward through the dust to meet light again, repeating the gesture until a shape emerges that is both biology and geology woven. In the Archean, we find ancient, lithified versions of similar shapes, beds of wavy laminae, columns with onion skin interiors, mounds whose surfaces are rippled as if a skin once stretched and wrinkled there. They are not confessions. They are the most honest way to read them is softly. These structures could be living architecture. They might also be clever chemistry and current. And yet, over long shelves and many horizons, their repetition, their quiet insistence, begins to feel like a whisper that returns because it has something to say. Picture a shallow flat on the shoulder of a young cretin. Tides comb it twice a day. Sun reaches it through an amber veil. The water is mineral-rich, mildly acidic in places, gently alkaline in others, where springs thread up from the rock and change the local chemistry. On the bed lies a film, not solid, not loose, something like silk and sand. Push a fingertip into it, and it resists, then yields, then returns slowly, as if recalling its shape. In that film, grains stick, then are cemented by precipitates that form when sunlight warms the thin layer and nudges its chemistry. Later, a storm lays a veneer of silt. The film responds growing upward through the dust, binding it, re-establishing its surface where light and flow again balance. Over weeks the surface lifts. Over seasons domes suggest themselves. Over years a field of low mounds like sleeping seals spreads, each one layered, each one the record of hundreds of small recoveries. If this is life, microbial mats at work, it is life without spectacle, thin communities of cells, sharing tasks, exhaling gases into water, drinking sunlight, or chemical gradients according to their talents. They make no bones, but they leave texture, wrinkle structures that look like the elephant skin of tide-wrinkled mats. Roll-ups where a storm peeled a mat free and curled it into a tube before it sank and was glued into the record. Polygonal cracks that seem too regular to be mere drying edges darkened by trapped grains. Surfaces smooth where a film once draped. On some bedding planes you can trace the faint imprint of bubbles that rose and caught under a skin and then popped, leaving tiny craters that were later cemented by the day's chemistry. None of these alone proves a living hand. Together, in long repetitions, they begin to hum. Silica is a faithful archivist of such delicacies, where hot springs fed alkaline waters with dissolved silica. Thin gels could precipitate at the surface and, in turning to chert, capture microtextures with startling fidelity. In some ancient cherts there are filaments and spheres that, at first glance, resemble microbial threads and colonies. Some have cell-like beads, some look like branching tubes. Many, seen decades ago, were celebrated as microfossils. Later work taught caution. Minerals play at masquerade, fluids can etch and deposit in ways that mimic life. Needle-thin veins look organic, until a larger pattern gives them away as chemistry's art. So we hedge and ask for patterns in company. Do the filaments live within a lamination that could be a mat? Do they align with flow? Do they repeat in beds that also show mat ripples, roll-ups, gas domes? Is there an accompanying geochemical whisper, carbon, that is isotopically light, sulfur that shows fractionations more easily explained by metabolism than by bland inorganic steps? When stones speak in chorus, the ear grows more confident, while remembering that the score has been altered by heat, pressure, and time. Carbon, in particular, speaks softly of preference. Life, when it builds itself, tends on average to select the lighter carbon isotope, M-ether-Hevesi. The result is organic matter, with a more negative value than the inorganic carbonates precipitated beside it. In Archean rocks, where so much has been cooked, stretched, and recrystallized, little flecks of graphite appear, black glitters nested in pale banded granite. In cherts, along old fractures, some of these flecks carry a light isotope signature, numbers that might say this carbon once rode through a cell. Might. The rocks were heated, fluids passed, isotopes can be shuffled, but across many samples and far-flung cratons, the recurrence of light carbon in ancient contexts becomes interesting. Not proof, but a repeated tilt of the head. Sulfur tells a different, older story, one written before oxygen policed the skies. Sunlight in a low-oxygen atmosphere can split sulfur dioxide in ways that leave sulfur's isotopes imbalanced in a quirky, mass-independent manner. A signature that is then passed to minerals when sulfur rains out or is cycled by microbes. In Archean sediments, such odd fractionations are common. They say the sky was breathless with respect to oxygen. They also suggest an active sulfur cycle, one where some of the work may have been done by cells comfortable in the dark, shuttling electrons between sulfide and sulfide, writing their small joys into pyrite grains that gleam like stars in thin sections. Later, when oxygen rises, this mass-independent quirk almost disappears from the record. For now, it is everywhere. A quiet starlight in sulfur that makes the air of our chapters feel honest. If some of the mats on tidal flats were literal, others may have perched at the edge of chemistry rather than sunlight, along the seam where iron-rich anoxic water met a shallower layer with just a hint of oxidants. Along the margin where a warm, alkaline spring bled into the sea, at the fringes of hydrothermal seeps, gradients abounded. Microbes, if present, often thrive on gradients. Some strains could have used hydrogen from rocks and CO2 from air to make methane. Others could have harvested a little energy from the gentle dance between sulfide and sulfate. Still others, in shallows with iron-drenched water, might have used light without oxygen. Anoxygenic phototrophs that take electrons from iron or sulfide instead of from water. A purple-green world in the making. Colors we cannot see here, but can imagine as halos in the mind's eye, when chemistry meets sunlight in quiet brine. In places, the shapes are bolder than mere wrinkles. Conical stromatolites, steep little tents of laminae, rise from ancient beds like a field of fossilized flames. Columns stand, some fused at the top into domes, some separate, evenly spaced as if growth and flow negotiated a respectful distance. In cross-section, their layers curve upward at their edges, each lamina stepping over the one before like shingles. The elegance of these geometries suggests self-regulation, something adjusting, correcting, aiming for a shape through time. Could currents alone, or purely inorganic precipitation, sculpt such disciplined forms? Perhaps in part, but the most parsimonious reading, many argue, is that films of microbes sticky, rebuilding, sensing light, did the fine work, while chemistry provided the glue. Elsewhere, the whispers are tucked into volcanic places. Hot spring terraces fringe old eruptive centers, silica lips that once fed trickles over their rims, pooling, cooling, gelatinizing. In those lips and pools, some researchers have seen textures that in modern analogues belong to microbial communities. Tubular casts where filaments once sat, mat-like drapes across tiny cascades, nodular clusters that resemble communities living in hot, chemically rich waters today. In our time, such settings are lively, bacteria and archaea writing their preference into the fringes of every vent and pool. In the Archean record, these suggestions live in chert, preserved with unusual fidelity. Are they life? The cautious answer, they could be. They align with places where life would have had energy and shelter. They repeat in ways that argue for habit, not accident. But rock can play tricks. We keep our voices low. Storms participate in preservation. When a mat field grows in a quiet season, it builds a low, sticky skin. A tempest arrives, tears tongues of that skin free, rolls them, and drops them into small depressions. Silt hurries in after and buries the rolls. Later, precipitation stiffens the package, cut it in cross-section millions of years hence, and you see rip-up clasts, curls of darker lamina, wrapped within lighter beds. The fossil of an ecosystem's bad weather day, paired with bubble pits, with gas escape structures that scallop the overlying layer, with surfaces imprinted by the fine grid of desiccation cracks, and then healed by the next flood. These bundles read like a diary, written in fits. Calm, growth, tear, burial, calm again. We are tempted, naturally, to seek faces in these clouds. Some ancient cherts hold tubes that look like filaments, beads that resemble cells, intersecting threads like simple webs. Early enthusiasm named and sorted them. Later scrutiny folded many back into a gentler category. Dubia fossils, things that might be life, but might also be minerals, rehearsing life's arrangements. Even so, a portion of the tiny things refuse easy dismissal. They occur within lamino we read as mats. They are truncated by erosion and healed by later growth. They make communities that fill space in ways minerals rarely do on their own. We let them stand provisionally in the choir. Lower voices, not soloists. If some communities loved the flat and the warm, others may have crouched in the dim and the cool. Pores in basaltic glass can be etched and lined by films that in the young ocean had access to iron and silica and the small comforts of being shaded from ultraviolet. Tiny tunnels wander through once vitreous surfaces like burrows. Their walls are mineralized in ways that suggest organic help. Later heat metamorphoses the glass to palagonite and other secondaries. The original materials vanish, the shapes remain. Again, we cannot be certain. But the place, the scale, the chemistry, they fit together like stones in a low wall that has stood a very long time. What would the air above such living films have been like? Breathless, as before, mostly nitrogen, water vapor, CO2, yet visibly altered in local pockets. Over a busy mat at noon, oxygen might have built a thin sheen in the boundary layer of water, microscopic bubbles rising and winking away, too small to summon an ozone sky, too fleeting to change the world, but real enough to matter to iron, just there, in that microoasis. Ferrous iron might oxidize and settle as a thin rouge. A meter away, where shade or current changed the game, no such film appears. The Archean is full of these small contrasts. Life, if present, painting in fingernail strokes, what geology will later blur into washes. Not all metabolisms, if any here, required oxygen at all. Some would have preferred its absence. Methanogens, should they have already emerged, found comfort where hydrogen from rock met CO2 in the dark. A chemistry available in cracks and vents, and beneath mat sulfate reducers and sulfur oxidizers could have traded energy at spring-fed interfaces. And oxygenic phototrophs, purple and green families in our time, might have drifted at depth along a chemocline where light still reached, but oxygen did not. Their pigments tuned to harvest wavelengths, filtered by haze and water. Their influence, writ large, would be quiet. A little drawdown of certain ions, a little precipitation of iron minerals, a slight tilt in isotopes. Enough repeated to leave layers we might feel with a fingertip as smoothness in shirt, as a color in a hand sample. There are grander claims in some stones, very early dates for life's presence in graphite inclusions within old crystals. Very ancient stromatolitic textures in rocks hammered by heat and depth. We greet such claims with a bow and a caution. Heat reorganizes carbon, pressure realigns layers. Fluids carry bits of old chemistry into new rooms and leave them there. It is possible that life's trace was preserved in those contexts. It is also possible that a geologic ghost dressed itself in similar clothes. Our lane in this quiet film is to honor the possibility and to wait for the chorus to grow. A striking thing about these whispers is how often they appear in places where energy gradients are ready at hand and where preservation is plausible. Shallow, sunlit flats with high sediment flux and frequent cementation. Hot spring aprons with silica gels and warm chemistries. Vent proximal settings where metals and fluids meet cold water. Porous glasses young enough to be etched, then swiftly sealed. These are the same kinds of rooms where today microbes thrive and petrify their own traces. It is not proof, it is taste. The world seems to have offered the right recipes often, and the rocks sometimes caught the aroma. In the presence of such suggestions, the imagination is tempted to draw a face on the Archean hue of mats at dawn. Sheen of bubbles by noon, faint earthy sweetness of organics in warm air after rain. We check ourselves, we keep to maybes, but we allow a little color in our palate. Perhaps the flats did have soft skins that caught your heel and released it with a sound like a kiss. Perhaps the smell after days of sun was slightly richer than stone alone. Perhaps the morning light filtering through a thin haze and then through a few centimeters of greenish water found pigments at work, brownish purples, olives, busy just below a boundary that shifted with tide. We will speak of metabolisms next, of energy before oxygen, of iron and sulfur's quiet trades, of methane and its sky moods. For now, it is enough to hold in hand a thin slab of chert or carbonate and tilt it under light. Laminae appear fine as sheets of paper, wavy as wind-riffled water. On one surface, a wrinkle field extends for centimeters, like a miniature desert of ridges and troughs. Along one edge, a thickened roll lies buried in softer layers. Flecks of graphite trace a filament's path and then vanish into a break. You run a fingertip along these slight rises and fall into the same slow breath the builders, living or not, once kept grow, bind, bury, grow again. Life, if it was here in these ways, did not yet change the sky. It changed the texture of small places. It altered the timing of cementation and the reach of ripples in fields no larger than a room. It turned inorganic precipitates toward more regular, self-repeating forms. It preferred light and gradients, and made use of each. And all the while the world around it remained as we have known it in these chapters. Amber-skied, breathless, warmed by a dimmer sun and a kinder blanket. We close with a low tide. The flats, wide, shimmer with a film of water, no deeper than a finger. Small domes glitter through rims, catching sunset, centers darker. A breeze draws cat's paw textures across the skin. In the quiet, tiny bubbles collect under small translucent skins, merge and wander to a place where they slip free. The pop is soundless at this distance. The scene is still. You might call it geology. You might call it biology's first theatre. Either way, it is beautiful, layered, unhurried, and easy to believe in. In the next chapter, we will lean closer to the chemistry of those small worlds and the dark ones below. How energy moved before oxygen was routine. How rocks and water and light paid one another in electrons. And how that commerce may have kept the planet gently warm. For tonight, let the whispers remain. Whispers. Sometimes the quietest chapters are the ones we remember most. Before oxygen had a say, energy moved along other rails. Rocks met water and made hydrogen. Sulfur wore different masks, and in changing them, paid a little interest. Iron drifted between forms that, under light or at an interface, could be nudged one way, then another, each nudge worth a few precious electrons. Light itself, softened by haze and filtered by water, still offered a slope to slide down if pigments could catch it. Begin deep, where the planet breathes into the sea. Alkaline fluids rise along fractures from warm, altered rocks, waters rich in hydrogen and small organics, buoyant and basic, meeting the colder, more acidic ocean, where the two touch. A thin border forms, a line of contrast in pH, redox, temperature. Minerals precipitate to make tiny walls, brickwork of carbonate and brucite and iron-nickel sulfides, porous like a sponge, crisscrossed with channels as fine as hair. Across those fragile partitions, protons stream, eager to balance the difference. Energy lives in that eagerness, in the urge to even out, to a chemistry that can set a turbine in the mind's eye. Some turnstile that lets protons through only when they pay in work. This is a gift. It is. Perhaps a hint that life's later trick of using proton gradients to spin its inner machines did not need to be invented from nothing. The world already made such gradients. It offered template. Think of the Archean as a dim room full of gentle batteries. Not the bright, crackling kind, but the slow ones. Gradients, contrasts, quiet differences that could be harvested by small, persistent chemistries. Imagine a thin, drifting layer along a chemicline where oxygen is absent but light still finds a path. Pigments catch photons. Tiny charges leap. Ferrous iron lurking below gives itself up to become a rustier form that will, in time, settle out as fine grains. The drifting cells in turn build themselves from carbon dioxide. They fix with the power they've just borrowed from the sun. No oxygen released. No sky changed. Only a local veil of green-brown life testing the day's gentleness. Up in the light, another slope waits. Sunlight in the Archean, after passing through haze and skimming into water, carries bands of energy biased away from the harshest ultraviolet, pigments that favor longer wavelengths. Browns, purples, bottle greens might have done well, and oxygenic phototrophs. Organisms that in later times use light but not water as their electron source could have taken iron or sulfide as the starting point. Light would lift an electron from a pigment. An electron-hungry compound would wait. The circuit would close through iron changing from ferrous to ferric, or sulfide stepping towards sulfate, with the cell pocketing a little of the difference in a chemical currency it could spend to keep shape and repair. Hydrogen, born of rock and water serpentinization, where ultramafic minerals meet heat and brine, feeds more than a gradient. It is a simple, potent donor of electrons. Mix it with carbon dioxide, add catalytic surfaces, iron-sulfur minerals with the right angles, nickel-rich grains with a talent for holding onto things, and small organics begin to assemble. A little formate here, a touch of acetate there, then perhaps longer chains under the right patience and pressure. None of this requires a living hand. But when, or if, small catalysts learn to steady these steps and to keep only the useful products close, a path begins to look like a metabolism, a way to harvest a slope in energy and keep some of it in molecules that can be spent later. Elsewhere, at the edges of springs and shallow seeps, sulfur holds court. Under a breathless sky, sulfur moves easily between reduced and oxidized forms, encouraged by light in the air and by catalysts on minerals. Microbes, if present, could sit at either side of this trade. One family, tucked where a whiff of oxidant meets a dominantly reducing world, might oxidize sulfide to sulfate, taking the energy difference as small income. Another family, deeper or in the dark, might take sulfate back down to sulfide, spending electrons scrounged from organics or hydrogen to do so. Around and around, with each step giving or taking just enough to sustain the dance. In the stone, the ledger for such commerce is written in subtle isotopic tilts, in the size of pyrite grains, in their textures, framboids like tiny raspberries that form readily under certain redox moods. Methanogenesis, a mouthful for a simple act. Carbon dioxide reduced to methane using hydrogen, fits this world. It is ancient, chemically spare, suited to places where basalt gives hydrogen and the ocean brings CO2, and where oxygen does not come to spoil the reaction. Picture a crack a meter beneath a vent flank, whisper warm, flowing with alkaline water, lined with iron-nickel sulfides that act as helpful benches. In that crack, each tiny chamber holds a gradient, protons, anxious to cross from the acid side to the alkaline side, electrons ready to fall from hydrogen to carbon, if given a channel. A community that builds channels, molecular wires, catalysts tucked in soft walls, earns its keep. Methane slips out as a fugitive, rising to the water where light will, in days, unweave it to other things. But while it lasts, it traps a little heat and smooths the planet's pulse of cold. Carbon pays attention to all of this. In the absence of oxygen, carbon dioxide has fewer obvious exits. Weathering can lock it in carbonate. Hydrothermal systems can write it into altered basalts. The sea can hold a portion as inorganic carbon, but living chemistry, if it was already at work, would have carved a modest path from CO2 into small organics, then into a resident pool of biomass that died and was buried as reduced carbon. Each burial is a cooling whisper, carbon taken from air and stored away. Each later exhalation by volcano or by metamorphism is a warming sigh. Over long laps, these breaths position the planet's temperature near liquid. Methane, born wherever hydrogen met CO2 in the company of certain cells, adds warmth while oxygen sleeps. A potent greenhouse that lingers longer in a low oxygen sky. If methane's voice grows too loud relative to carbon dioxide, an organic haze builds and throws a parasol across the sea, a cooling that answers the warming like a counter-melody. The Archean may have hummed through such verses, warm with methane, cool with haze, warm again as chemistry and sunlight renegotiated their lines. Closer to sunlight, but still shy of oxygen, photopherotyphy suggests itself, a word heavy with meaning and light, with image. Light-driven oxidation of iron, ferrous iron, plentiful in an anoxic sea, absorbs into the lower water column as a quiet greenish note. Where light penetrates, pigments raise electrons. Those electrons search for a fall and find ferrous iron chill and ready. In giving up an electron to become ferric, iron changes its solubility. It prefers to precipitate as fine hydroxides that gather into flocculent clouds. These clouds rust in its softest infancy, settle to the bottom as thin red-brown sheets, later pressed and altered into the ironstones we will meet next chapter. Whether phototrophs wrote these pages widely or only in certain calm basins is a question, but the logic of light, iron, and no oxygen has a gentle composure that fits the Archean sea. Acetogenesis, another ancient road, may have walked beside methanogenesis. Again, hydrogen, again CO2, but the end is acetate, a two-carbon small and useful molecule that can be both fuel and building block. The chemistry makes sense on mineral surfaces, at pH interfaces, in the presence of iron-sulfur clusters that later inside cells will be the cause of enzymes doing similar tricks. The motif repeats, a gradient across a thin wall, a catalytic surface that stores and passes electrons, a product that carries away a bit of the gradient's value in a form that can be saved for later work. If life built itself in such places, it did it by borrowing the planet's ready-made patterns and miniaturizing them, turning a vent field's architecture into a cell's. There are other gradients to imagine a cell testing. At the interface where warm spring water meets cool ocean, heat itself organizes reactions. Rates quicken and slow across a centimeter. Minerals nucleate, then dissolve in tiny adjacent rooms, each room a different invitation, where CO2-rich brine exhales into a tide pool. pH can swing with a gust. A film that catches more light as pH rises can capitalize on a minute's advantage. Where sulfide-rich seepage skirts the edge of a platform, a breeze can tilt the chemistry enough to give oxidizers a little windfall before the tide turns. None of this is dramatic. It is fiddly, and that fiddliness is oddly compatible with life's nature. Small wins, repeated, accumulated. The chemistry inside such rooms would have felt a family resemblance to modern cells, minus the dependence on oxygen, proton gradients doing work, iron-sulfur clusters shuttling electrons with the gravitas of antique coins, INADH-like currencies to store small victories, ITP-like tokens to spend those victories on stitching molecules together, patching membranes, keeping shape against diffusion. The difference is in the sources and the sinks. Hydrogen instead of sugars, CO2 as the starting carbon, instead of a pantry full of ready-made organics, iron and sulfur as friends instead of oxygen as partner. It is not lesser, only different music. And outside these micrometers of enterprise, the planet listens and replies. The planet listens and replies. Methane emitted at depth or along flats floats up, and until sunlight takes it apart, warms the air. If it grows too bold, haze spins itself from methane's fragments into a gauze that cools the surface while protecting delicate chemistries under it from ultraviolet. Volcanic exhalations deliver fresh CO2, shifting pH and feeding carbon-starved films. They also bring sulfur that thickens the menu of redox options. Hydrothermal cycles pull magnesium from the sea and push calcium back, tipping carbonate saturation in ways that decide if a mat is buried in soft mud or armored by a thin stone. Protection that increases the odds of being remembered. When oxygen does appear, in fleeting glows over busy mats, it creates local dramas. Ferrous iron, which the sea carries like a dissolved secret, meets the tiny plume of oxygen above a sunlit film and becomes right there, a smear of ochre that cements grains and stiffens laminae. Manganese does likewise in its own palette, darker, sooty. A meter away, shadow protects ferrous iron, and nothing settles. The result on the page is a banding finer than a fingernail. Light layer, dark layer, the biography of an afternoon written in rust and silica. Multiply that by a season, a year, 1,000 cycles, and you have a rhythm in stone that could echo the beating of a metabolism too modest to reach the sky, yet strong enough to organize its room. There is a patience in how these systems likely behaved. A community that depends on hydrogen keeps its shape only as long as the fracture breathes. When the pulse quiets, it goes to sleep, wraps its enzymes with protective folds. When a new vein opens a few meters away, fragments drift, reattach, start again. On the flats, films grow while the weather is mild, then peel in a storm, then grow again. Nothing is permanent. Everything rehearses. The survivors are not the fastest. but the ones most attuned to tiny slopes in energy and to the habit of saving nickels for lean times. We have not yet invited oxygen to reside in the sky. In the Archean's long afternoon, energy flows without that blue partner. The planet stays warm enough through greenhouse blankets and not too bright mirrors. The seas stay modestly busy. The rocks feed the water as the water edits the rocks. Life, if living in these ways, learns to be thrifty, to be local, to be content with gradients that shift with tide and season. The art is one of enough hydrogen from stone, enough light under haze, enough sulfide in a trickle to sustain a film for a month, enough burial to hide a little carbon before a hungry mineral can steal it back. On some days you would not see any of this. You would only see the surface, the quiet green of shallow water over black rock, the drifting threads of steam where a spring finds air, a shimmer as a wavelet flips and briefly shows you the sky. The chemistry would be a rumor under your feet, a low current. On other days, a thin smell would hint sulphurous near a seep, faintly sweet over a warm flat at noon. Bubbles would tremble under a skin at low tide, gather into a lens, and let go with a soft gummy pop. If you cupped the water and waited for the film to settle, perhaps a faint iridescence organics at play would show itself in the slant light. This chapter's commerce, slow, mineral, sunlit at the edges, sets the table for Iron's great script. For as long as the sky is breathless, Iron wanders the sea as a soluble guest, ready to be called to the floor by light at a boundary or by the tiniest exhale of oxygen at a map. In the next chapter we will watch those calls lay down broad-banded pages. Iron dreams, rust, written as time. The tone will not grow louder, only wider. The stripes will be long enough to outlast continents. For now, hold a small imagined bead of pyrite between finger and thumb. Cool, heavy, the color of straw in shade. Turn it. In its glint is a memory of electrons that once paid for a life's tiny debts, of an interface in warm brine, of energy before oxygen, conserved with care, spent with grace. There were nights in the Archean when the sky wrote louder than the sea. Not always, not often as time went on, but sometimes the heavens sent stone. Most of it arrived as light, a drift of meteors, threads of fire unspooling across an amber dusk and fading with only a sigh. Some came larger, bright enough to cast moving shadows on black shores, a white flare, then a low, delayed thump that travelled through rock like a memory. Rarest of all, a body big enough to speak in heat and pressure, a visitor that made the atmosphere ring, that leaned on the ocean until it forgot itself and ran. The age of constant hammering had eased by the Archean's long afternoon. What some imagine as an earlier storm, an era of frequent, heavy blows, was likely giving way to sparser punctuation. Even so, the punctuation marks were legible. The sea, being wide, caught most of what fell. Impacts that met water threw up curtains of steam and salt, jetted hot droplets that cooled into glassy beads, and sent waves across basins with the slow authority of the moon's own breath. Only taller, deeper, more sud coasts with no roots to hold them were easy students. Bars were erased and then redrawn miles inland, flats reorganized, channels rekeyed like musical phrases. What the sky wrote down, the rocks preserved in their careful ways. In some Archean layers, there are thin beds of small rounded pellets, spherules, grains the size of seeds and peas, glass once, now recrystallized into delicate mineral mosaics. They fell from high plumes after a large strike rock vapor blown into the upper air, quenched into droplets, then rained back through a wind that sorted them into a blanket. Set your palm on such a bed in imagination. It is granular, subtly graded, coarser at the base, where the first heaviest beads fell into a rising sea, finer above as the shower thinned and ash joined. Sometimes a faint horizon of broken shards sits at the bottom, a low, bright line where shock and surge first touched down. Between these spheral pages are the quieter texts of the old world. Iron-rich laminae chert, thin volcaniclastic veils. The contrast is striking. Calm, 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 and then a breath held in stone. A rain of glass you can almost hear. If you follow one of these beds along an outcrop in your mind, You may notice ripples impressed into its upper surface by waves alive in the event's long echo. You may notice, too, a soft enrichment, tiny flecks and flavors that hint at a visitor's nature, metals uncommon in everyday sand, an unusual balance of nickel or platinum-like friends. The details are sparse and debated, but the mood is sure something from elsewhere turned local for a day and left a calling card. On the day itself, the sky would have become a lens of light, a streak, a silent noon, then sound and wind, pressure running ahead of heat, bending grasses if grasses had existed, pushing sheets of water hard against their basins. Over ocean, a tower rose where water met stone, steam, salts, silicates ground to powder and thrown high. The first waves radiated away as green-black walls, glassing coastal ledges and combing bars into new arrangements. Minutes later, the air began to snow, little pearls from a world made briefly into mist. They struck with soft ticks, then with hisses where they met standing pools still warm from passing air. The scent was metallic, mineral, like rain through dust warmed on a stove. Nights after such a day were strange. The upper air kept a faint, milky veil, as if the sky remembered the shock. Sunrises glowed wider, sunsets held their red longer. Rain might have come sour for a while, where gases made in the flash met water. The sea, with its enormous patience, took the acidity and spread it thin. Rivers, for weeks, carried extra glass and ash from slopes bleached by the blast. On estuarine flats, you could have read the event in couplets, a thin, gritty line trapped at the turn of tide, then a calmer silt above, then at springtide, another whisper of beads reworked and laid down in delicate fans. Volcanoes added their own stonefall, indistinguishable at a glance from the sky's gifts, except in the company they kept. Ash drifted from distant arcs and settled as grey snow, sometimes for days, sometimes for a single, quiet night. Tephra layers are soft pages in the record, easily reworked, but when preserved, crisp as tissue pinchable between finger and thumb. In places, an ash fall and an impact spheral rain might lie close in time, their signatures interleaved, a world busy on two stages above and below, each writing fine print into the same book, to the water and the wind. Both were simply grains to sort, to the chemistry of tide flats. Both were new surfaces to coat, to tame into laminae. Impacts did not always wound, sometimes they delivered. Bodies from colder spaces carry organics and water bound in minerals, cargo that, melted and spread, could have added a trace of complexity to local pools. A little feedstock for the patient chemistries we lingered over in warm, dark rooms. The amounts were likely small at any one place, but over long seasons of stonefall, cometary dust, fine meteoritic flour drifting always down, the planet's surfaces learned the taste of carbon-bearing crumbs fell from space. Perhaps a mat perked up for a week when such dust was thick, or a vent field droplet line gained a new flavor that stuck to iron-sulfur corners just a breath better than before. The cadence of skyfire slowed as the eon matured. Big craters were made, and then erased by the same rude youthfulness that made them. Oceanic crust turning over, volcanic blankets, resetting the clock, metamorphism ironing wrinkles out of shocked rocks, until the shock could only be inferred from small survivors. What persisted most faithfully were the fallouts, spheral beds protected by quick burial, thin metal-enriched lines, barely thicker than a fingernail, subtle arrangements that a later eye could trace the way one traces growth rings in a tree. The noise of the early solar system softened into background. The planet's own weather and vents reclaimed the lead. Storms in the sky not born of stone, those long, convective towers from Chapter 4, quieted too in their statistics as basins and shelves found more steadiness. Not gone, only less startling to the land as margins strengthened and the first wide platforms of Cretan learned to shrug. Lightning still found the open ocean by preference. Thunder still rolled across black beaches, but the sky's longest violences grew rarer. Even tsunamis, when not summoned by spacefall, spoke mainly the language of faults, rare slips along young margins, rather than the sea-wide roar of a strike. Stand with me for a moment. On a ledge above such a record, below your boots, a thin dark seam glassy grains, rounded, sitting in a band the width of a hand. Above, A return to calm sediments. Shirt iron soft dreaming. A pale carbonate veneer, faintly laminated. The seam is not dramatic. It is precise. You could trace it along the outcrop until a fault hides it, then find it again meters away and feel the same texture, hear the same delicate rasp under a thumb. It is the sound of a day when the sky spoke loudly enough to be remembered for billions of years. Remembered not as ruin, but as punctuation, in a sentence otherwise written by tides and light and the long, low hum of chemistry. Some spheral beds tell of multiple pulses, coarser beads at base, a thin ash, then a second finer rain. Evidence that the sky can cough twice. Some write only a single syllable, one tidy carpet, then silent. The individual stories are small. Their comfort is in the chorus, fewer with time, farther apart, the planet's room growing quieter. That quiet is not emptiness. It is opportunity. Mats, if present, had longer runs between disturbances to build and bind. Carbonate films had more evenings to learn thickness. Iron's dreams could unfurl in longer, more regular ribbons. If there was fear in the day of a great strike, there was sleep after. Air cleared. The sea resumed its breathing. The moon lifted and laid the tide back down with the same old hand. Even the glass fall, once blanketing the flats, became, under a dozen tides, merely another sand, another set of grains for water to teach. That is the grace of the Archean world in this telling. It absorbs drama and returns to poise. It is built, more and more, to keep its own balances. Lighter keels below, broader shelves above. A sky that, while breathless, knows how to hold warmth and let color pass. We will carry that poise into a gentler conclusion. In the final chapter, the air will not turn blue. Not yet, but we will listen for the first long exhale toward oxygen, the toward breath that hints at futures. We will let iron's dreams thin, let mats, if they were there, catch a little more noon, and let the oceans whisper of changes that will take their time. For tonight, rest with the notion that even the bright shout of stone from space was smoothed by water and remembered by thin, graceful lines. The world's lullaby, already, was longer than any single day's alarm. There is a moment, late in the Archean, when the day seems to hold its note a little longer, as if the sky, still breathless, were leaning toward a different chord. Perhaps the change begins in inches on flats we have visited, where films thicken and domes lift, where noon light presses through a hand's depth of water and asks pigments to do more than they did the year before. Perhaps it begins in shallows over pale shelves, where currents are slow and the tide's polish is gentle, where a mat, busy and unshowy, raises a micro-shimmer of oxygen and keeps it for a few minutes longer with each season. Call these places oases, if you like. Oxygen oases. Local, transient, there at noon, gone by dusk. Small blue thoughts on a planet that still thinks in green and grey. In each, iron meets a new fate. Ferrous turned ferric at the very surface. The hushed blush that stiffens laminae and leaves hair-thin stripes, bright as breath marks. A finger's width away, shade returns chemistry to the old mood. The sea in this tide pool scale holds 2 times at once, the Archean and something just beyond it. The workers in these rooms might have been the old films doing a new trick, oxygenic photosynthesis, perhaps already rehearsed in late Archean hours. It would not have made a sky in a single summer. It would not have redrawn the horizon. It would have made moments, microclimates tied to light, ribbons of oxygen skimming mats and drifting centimeters into water, small oxidizing halos where iron fell out and sulfur changed its manners. Multiply moments by ages, multiply oases by coastlines, and the ledger begins to tilt. Not loudly, quietly enough that most days feel the same. Amber light, bottle green shallows, iron dreams in deeper basins. But some things notice. Iron in the open ocean finds fewer places to roam before a face of Occident stops it. Banded rhythms thin here, thicken there, as if the pen were running low and then catching again. Tiny bubbles, once gossip, become habit, where flats lie wide and weather is kind. The air, still breathless by any modern count, begins to practice. Sunlight in the upper sky splits water and methane, and builds shy oxidants that, meeting a world less greedy for every electron, last a little longer. Methane, when it grows bold, still paints a cooling veil, yet the balance flickers, haze thick one decade, thin the next, guided by photosynthetic appetites that change how much carbon floats as gas and how much settles as quiet black in mud. On land, what little land stands, something subtle follows from these local breaths. Grains that once travelled as bright, reactive metals in streams now blacken or crumble sooner. A glint of pyrite, a shard of uraninite. Fewer reach the sea unchanged in the very latest pages, not a law, a trend, a suggestion that even far from mats, puddled oxygen and its cousins were beginning to patrol puddles and banks, if only at noon, if only in the wake of rain. Sulphur's starlight, the mass-independent quirk we felt earlier, glows on through most of the Archean, then dims toward the edge, as if a thin, new filter were being drawn across the lamp. Not a curtain drop, more like a cloud that spends longer over the stage. Oases change neighborhoods. What was safe for the old metabolisms at dawn becomes unfriendly by afternoon. They step downslope, deeper, into shade, into fractures, into the warm dark places that do not care what the sky is thinking. Newcomers, if the oxygen trick is real and spreading, learn to sit nearer the top, to love full noon, to braid their days with tides, to accept that afternoons taste faintly of rust. If you could climb a basalt headland and look long across a late Archean shelf, you might not see anything you could name as different. The sea would still be graphite under cloud, emerald over shoals, the air still tea-tinted at the horizons, but you might catch, in the shallowest pans at low tide, a silver sheen that mends itself more quickly, bubbles that hang in chains, a touch longer before slipping free, a veil perhaps of water that smells just slightly brighter than stone. The planet, in its long balances, begins to set the stage for a future turn. Keels below hold shelves steady enough for laminae to stack without interruption for years. Weather learns patience. Carbon finds a few more ways to rest, a solid, tucked-in quiet. Iron's big pages thin in places, and somewhere in the arithmetic, a threshold waits, the one that will, later, tip air from breathless toward breathing. We do not cross that threshold here. Our film closes with the light still amber, the ocean still mineral, the sky still more mirror than window. We stop on the intake, on the sense that the room has changed temperature, by a degree you only notice when you step outside and back in again. The Archean exhales, and you can almost taste, on the edge of evening, the faintest cool of something like tomorrow. Night comes as it always has. Stars fill the hazed dome. The moon draws its bright path on water and lifts it, gently, onto black stone. Somewhere, a chimney keeps breathing. Somewhere a mat keeps its film until starlight thins it, and the world, not hurrying, turns toward breath. Perhaps that is the comfort of this long walk through an early world, that nothing needed to be sudden to be beautiful. Heat learned patience, water learned shape, stone learned memory, life, if here in films and whispers, learned thrift, then reach, and the sky, in its own time, learned to hold a brighter color,